It's my privilege to introduce to you Professor Ian Yield of Massey University via Scotland, once upon a time. I've heard Ian speak on a raft of different things about different products in the last 10 years, and it's always interesting because it's like looking into a crystal ball, and it's hard to, it's amazing imagining what will be 10 years down the track. So hyperspectral imaging and its uses, but I'll leave you in his hands.
Right. Okay, thanks very much. Okay, although I'm presenting it, there's quite a team of people that work in this area now. There's got quite a few younger staff. I forget how many staff we have, but we've also got quite a number of students. So it's not just me. I seem to just sign the checks and keep the reports, do the reporting now, rather than getting out in the field. But so what is hyperspectral imaging? Well, I think it was Ernest Rutherford that said there's two types of science. There's physics and there's stamp collecting. And sorry, was it? If it's not physics, it's stamp collecting, something along those lines. But this is physics, but I'll try and keep the physics to a minimum. And what I'm going to try and do is explain to you what we're doing, why we're doing it, and what we think the benefits will be. Okay, so hyperspectral imaging. Now, a lot of what we're doing, and a lot of what I'll describe, is around a project that Ravensdown and MPI. So MPI, you know obviously. Ravensdown, most of you will know. It's called Pioneering to Precision, and there's a number of objectives of the project, and it's to look to use remote sensing to better inform fertiliser application in hill country. So that's the basic aim of what we're trying to do, to estimate soil fertility and productive potential from the air by sensing the vegetation on the ground. So what we're not going to do is we're not going to go tramping around taking lots of soil samples. We do that while we're calibrating the sensor, but we want to be able to do it from the air and work out what your fertility is. To use computer-controlled hopper to improve delivery accuracy. So that's a computer-controlled hopper on a top dressing plane. So that type of technology is here now, and we're using that. So the reason that we used the title Pioneering to Precision was really, I suppose, in deference to the fact that the top dressing industry was a genuinely pioneering industry, that it was necessary in terms of getting fertiliser on our hill country. After bush was cleared, we had a lot of trouble then maintaining fertility. But modern aircraft, bigger capacity, and what we're doing is putting computer control systems in those to control where the fertiliser goes. Okay, here's a map of my favourite part of Palmerston North, the golf course. That's a map that shows just, if you like, the visible part of the spectrum. So those are the parts of the spectrum that we can see. So there's a thing called an electromagnetic spectrum. Part of it's called the visible, and that's the visible part of the spectrum. Here's part of Massey University, New Zealand's premier agricultural university. I thought I'd better get that in. But we do some, again, just an image of some of the university farms, dairy number 1, part of dairy number 4, part of the campus. Now, every pixel in that image has about 440 different layers of information on it. And okay, we can see different colours, but this sensor sees a lot more than just different colours. So hyperspectral imaging or hyperspectral sensing is an extremely versatile technology. It was actually first worked on in 1929, so nearly 90 years that it's been, this type of technology has been thought about to actually being executed now. So what are we doing? We're looking to estimate plant nutrient concentration from the air. We want to estimate the nutritional value. By that I mean ME, digestibility, so on. We can do, again, we think we can do that from the air. Species present. So the species of grass that are present are actually quite important to working out the fertility. And again, we're working on being able to identify the species of the grass. So that will help you in terms of your management of the grass, and also give you quite a few clues around the fertility. So it's like a forage test for every square metre of the farm. Okay? So we don't have to just pick a few points and make all our estimates on the basis of a few points. We actually measure the whole area of the farm. So it's got scale, and we can use it, visualize. You can imagine we're generating a lot of data. Nobody's really interested in data, but if we can give you visual images of what you've got, then we think that's a far more usable thing to do. And visualization of data is going to become more and more important, I think, in the future, because there's so much data. You know, a lot of people have a fear of data, fear of getting drowned in it, fear of they talk about a tsunami of data, they talk about data graveyards, data lakes, you name it, and it all comes from a fear of data. So we've got to get back from data to how do we present you with the information, and that's kind of my job, if you like, or part of my job. Okay, so I said that there's, this is the technical part, okay? So along the bottom line is, the first part says vis, so that's the visible part of the spectrum. So that's the wavelength, and those are the wavelengths that we can see. So I can see there's a few orange lanyards because it's within that part of the visible spectrum. There's blue shirts, yellow, red. These are all parts of the spectrum that I can see. I can't see what's happening in the infrared, so this, or the near infrared, that's the red part in the middle, and I can't see, or you can't see, what's happening in the shortwave infrared, but these instruments can. So just as I can recognize that that's blue, that's orange, that's green, these sensors have a lot more information that they can go on. So all sorts of things at different parts of the spectrum. So like, for example, chlorophyll absorption, we can see when something's dark green and when it's light green, because the dark green absorbs more light and therefore it appears darker. The opposite happens in the near infrared, it actually appears lighter. In the shortwave, we can start to work out what's actually happening in the biochemicals in the plant. So that gives us a lot of information. We can start to find out different things about the actual plant itself. So by combining all of these things, then we can build up a really accurate picture of what's actually happening. Okay, so that's all I'm going to do in terms of the physics. I've probably offended anybody that has a knowledge of physics. I've probably offended them, but that's basically how it operates. So what we do is, first of all, we used to use sensors, and I'll explain a bit more about that. But what we do now is we fly with an aircraft. It scans, as you go back and it goes back and forward. As it scans below the aircraft, builds up a picture. So each layer of information, so this camera has 448 layers of information on these different wavelengths along that spectrum. Okay, so every pixel has that level of information on it. You can see that it's a military aircraft, that's where this technology came from. So again, there's a picture of Massey. It's a survey we did recently. You can see the strips. So you can see we've basically flown it north to south. Unfortunately, we've just missed the race course here. Wasn't kind of on my radar at the time. I was more interested in what was happening at the farms. But you can see the strips. We go up, down, and then what we have to do is we stitch the image together. So that's not a trivial exercise. So we've got a team of people that can do all of that type of thing. And again, that's just the information that's in the visible part of the spectrum. Okay, then it starts to get more interesting. So what we did previously is that we used to use sensors that we would have to carry on our backs and go around a farm and make measurements. But what we were able to do with that was we were able to prove that the technology actually worked. So the top line is if you were to prepare a sample, like there's a bagged sample, and compare it, say, to a lab measurement, you'd actually get very close agreement. If you go out in the field, you don't grind the sample, you just take a fresh sample. Okay, there's a bit more noise in the data, but you actually still get, if you look at the sites, there's red triangles represent one site, then, it's a bit noisier, but it's still pretty accurate. So we thought, well, that's pretty good thing, but we could identify different sites on the farm, and you can see from that table that there are one site there had pretty good pasture quality, one very poor. Now, this is a 2,500 hectare farm. we're not going to tramp around a 2,000 hectare farm to prepare samples and do all that. So there had to be a better way. So that's why we go from doing it from sensing to imaging, but it's where we sort of cut our teeth in this type of technology. So we know that it works, we understand it, and we can work with it. So what we then did was there's this evolution between sensing, getting away from the laboratory. The laboratory, if you send samples to a laboratory, it takes you a day or two to get the results back. The sensing, at least we could do it instantly, but it's limited because what we want to do is image the whole farm. And there's the equipment in a plane there. Okay, so it doesn't fit on a drone, it's too heavy, it's too valuable as well. I wouldn't put it in a drone. Okay, so what we then have is just a bit of a collage, if you like, of different images. From your left, that's just part of a strip, and then you can see the diagram below. It's just the part of the spectrum, and those signatures are the spectral signatures of different parts of the scene. So there'll be some road, some bush, some grass, and so on. So we use that type of information, and this next map is a map of nitrogen concentration on a farm. Okay, so that's part of I forget if it's a 600 hectare block or 800, but that's part of a block of land that you can see we've taken out the trees. We don't use, we classify them out, but this is the pasture. We recognize what's pasture. And the red areas are where you've got a higher concentration of nitrogen than the green areas are a low, the yellow areas are somewhere in between. Okay, so we can map out, there's an example with nitrogen. So just to show you in a bigger scale, just to get you an idea of the level of detail that we can produce a map from, or make a map of. So that's the level of measurement that we're doing. The other advantage with this type of technology is you don't take one sample to do one thing, you fly it once and you get a whole lot of different information out of it. So hopefully, if I've got the order right, so ME, so clearly ME is pretty important. A lot of people realize that it's variable. This was in autumn. Probably didn't realize how low it had got in some areas. So again, we often, I think, soften the results a little bit in our human way. But if you can measure it, okay, what would how could you what class of stock would you put on some of those areas? What would be your expectations in terms of weight gain or actually maintaining weight and so on? So in terms of a management tool, we think that there's a lot of useful information for farmers. So it's not just ME, there's a whole lot of other things. So another thing is that it's important that if it works on my farm, then it works on yours, and it works on your neighbours, and it works in the South Island, and it works all over the country. So that's partly what we're doing now, is that we're looking at 8 different farms. We're in the research phase. We've got until, well, basically, we've done most of the measurement for the research phase. Each farm, there's 80 sites on each farm that we'll take 5 different samples from, and we use that to calibrate the image. So we use all of that information. It's a big cost, but it's worth doing well. Then what we're trying to do is, can we come up with a calibration that we can use it nationally? Because a lot of the problem is that you might find that you get a good explanation on site 1, and you go down to site 8 and it's not so good. So what we're trying to do is build a calibration that will be robust for the whole country, and that will make life a lot simpler. So what other things can we tell? So as I mentioned, it's very versatile data. So there's your maps of NPK, sulfur, copper, magnesium. These are all the concentrations within the pasture. So things like copper came up as an example that people were interested in. Are there areas or times of the year where copper is deficient? And clearly there were. And so, there's a lot of debate around what should I do around copper. So this type of system would actually assist in giving you a lot more information. NDVI is just like a vegetation index that we use to look at, say, how green something is and how well it's growing, how much of it there is. Dry matter is obviously important as well. Okay? So extremely versatile data. We can also, because we're got the data in such a fine format. That's the same farm, and I think, what's that, potassium concentration in the pasture. We could, I mean, probably not many of you would want to look at the map on the left, you know, unless you understood the landscape. Then, well, okay, the middle, at this stage, okay, it's interesting, but it's still quite variable. Well, you might want, if we're going to program an aircraft, we might want the map on the right-hand side that will tell us, you know, make our plan according to that type of information there. We can also go into 3D, and hopefully, if the chap can press the button. Yep. Oh, sorry, I didn't see you behind the screen there, he's sitting away down. Okay, some of you may have seen this, might take a wee while. We can incorporate also just the terrain information. And this is again, this is the colour image, and we'll just show you the level of sensing that can be achieved. You can actually, on a decent projector, you could see the sheep on here. And that's the farm that we've been measuring. So we could populate that with your nitrogen, with your ME, with, you know, any NPKs, those sorts of things. You could populate your map with that information for you to start making decisions. And obviously this is why Ravensdown are doing the work, or we're doing the work for Ravensdown. Okay, so I think again that because there's so much information, we're going to have to find much better ways to give you the information. So how do we do that effectively? Okay, so that's just an example of 3D. Obviously, you know, you can do it over a farm, over a whole catchment, and so on. There's a lot of interest in doing it over different scales as well. Okay, so back to why and what the process is around the project. So we've been tasked mainly with the remote sensing part of it. So the idea is that you fly over the farm, you sense what you've got in terms of the soil fertility or in terms of the vegetation cover. That then informs what you should be doing with your top dressing. Okay, then we've got the computer controlled hopper, and the idea is that we will grow more grass. And there's a fair bit of evidence to suggest that we could grow an awful lot more grass if we got it right. So we did some work about 10 years ago, just looking at how we can tidy up what a pilot does. And I know there's a pilot in the audience, and I'm not trying to offend anyone, but we've got to, I think, being an ag pilot is actually a pretty strenuous type of job. It's exacting. You've got to know exactly where you are in terms of where you are in your airspace. You've got to control a hopper. You've got to do a lot of different things. And we think that this type of system and this technology will make life a lot easier. So there was one, that was just an early example where we're looking at, the bottom one was where we're looking at monitoring using the boundaries and using the aircraft to recognize when it was on a boundary and switch off and switch on. Okay, and we think we can get aircraft to be as accurate, if not more accurate, than trucks over even gently rolling land. Trucks are not accurate over rolling country. Okay, you've got a lot of issues going on there as well. We think we can improve aircraft spread patterns by quite a margin. Okay, so that's why we've done quite a lot of performance testing. And again, quite a laborious type of thing, and you can see why we have a big team up the front there. So we've been doing a lot of performance testing of the aircraft. Here's a map that was done last year, I think. And this shows you just different rates on a property. It wasn't, it was just pre-programmed. It wasn't using the variable rate in terms of each block got a uniform rate. The important thing as well is that the aircraft, the hopper's control is linked to the speed, so that as the aircraft speeds up, then the hopper will open. That's one of the biggest factors that gives you variability in your spread rate, is the hopper door opening and your speeds are changing as the aircraft's flowing. So what this one was successful in doing was avoiding a lot of waterways, some unproductive areas, gullies, all of those sorts of things. And again, that's something else that can be put into the maps that we showed you to begin with, that you can have that level of detail in the map, that you might have areas that you want to avoid completely. Okay, So again, it's a technology that's, it's moving forward pretty quickly. So, as I say, I think I've summarised it, but can avoid sensitive areas, unproductive, less tiring to fly, apply different rates automatically, so we could do that in a single flight line, we could change rates, more accurate, less variable, compensate for changes in airspeed. So there's a lot of different aspects to what's going on there. There's just an example. This was up north, up in Limestone Downs. We looked at a paddock. This is about a couple of years ago. But again, just doing some tests. The middle paddock we wanted to put at a much lower rate, just for test purposes. Could we do it? And we found that, yep, we can manage to control the hopper sufficiently to allow those sorts of things to happen. So it gives you a lot more flexibility, a bit more freedom, can avoid a lot of those areas that you might think are pretty marginal and so on. So as I say, it's going to take a little bit of time to work out exactly how we're going to do all of these things. And I think that's where there's going to be a lot of engagement with farmers to suss out. Everybody's different, everybody's going to want different things. So there's going to be a lot of toing and froing, I think, just to work out what exactly people will want, because there's no one answer. Other things, I didn't put the table, I don't expect you to read, but what it was is different things we can do. So we've already mentioned calculate the effective farming area of pasture, detect the difference between grass species. So if we know the difference between brown top and ryegrass, then you're clearly going to farm that differently. Certain times of the year, you'll know where your clover is. Kikuyu, all of the, well, maybe not down here, but further north where we've got kikuyu. All of those things can be detected. And the sensor, we did some experiments, and the sensor was about 96% successful in trying to distinguish, or the technology, not this particular sensor, the technology was successful in even discriminating between different types of ryegrass. So that's the level of detail that we can get down to. So clearly, very detailed explanations of what's happening. So there's just an example. The three ryegrasses, I think, are the bottom row, left-hand side. So I think most of us would be hard pushed to tell the difference if you were looking at umpteen odd samples. So, but this technology can. So again, one of our other PhDs working on that. Okay, so where we've gone from is typically your Ravensdown or balance rep would come out and maybe do 3 transects on a farm, might do 4. But the transect would be, say, maybe do 27, takes 27 cores or some number like that, mark out where they've been, put it in one bag, and you would make your decision on however many hundreds of thousands of dollars or tens of thousands of dollars you were going to spend on fertilizer on the basis of that information, plus some other bits and pieces that you'd be able to put together. What we think we can do is give you a much more data in terms of how do you make that decision. Okay, so again, bear in mind what I'm illustrating to you. Remember, you saw, I think it was Craig's presentation about the idea, and then we're probably halfway through the second stage. This has got a bit to go yet, but the technology works. The information, we know that we can provide a lot of useful information. It's how we do that in the future. So, what I was saying about data, we go from 3 transects over 3,000 hectares to 4.5 million data points per hectare, which works out at about 13.5 billion data points for the whole farm. Again, not your problem, my problem. I've got to try and work out ways to get you useful information from all of that data. And that's the sort of thing that's what we're busy working on at the moment. Okay. So we call it the new data economy. So data and visualization, really important. I think it's a completely new concept in the way that we'll farm in the future. It'll be much more data driven. I think a lot of you are also, I think are based on observation, and you look at your own property, you make observations, you use your knowledge, you try and improve your knowledge, and you're reflecting all the time. Whereas I think that previously a lot of the science has been based on careful experimentation and a bit of trickle down at the end. Whereas what we're doing now is giving, there's a whole lot of data up front, And it's like that's a similar process to what you would go through. You would look at the information, try and start to make up your mind about it. So I think the science process is also going to change how we do things, and hopefully we'll get some rapid uptake. Clearly there's an issue around rural broadband. There is no point in me sending you terabytes of information if it's going through your phone line. So there's lots of issues like that we've got to resolve. We're trying to reduce the amount of information that we would send you, but clearly there will still be some. So yeah, there's a lot of challenges ahead. So it's not if you would say, done and dusted yet. Okay, other things that I think are quite exciting that we can do is this is the sensor that we use, the box with the orange stripes. Doesn't look much for 600,000, but that's what you get. And the box of tricks next to it. We can put it on a tripod. So I could, for example, look around this room and I could make an image of the room, and I could get all the hyperspectral information. Now, why I'd want to do that, I don't know. But anyway, that's what I could do. But where it might be useful, so this is just an example where, if you look at the table, the chart, there's roadway, soil, a white ute, and vegetation, and each have their own spectral signature. So what we could do is things like in a meat plant, we could look at carcasses as they go by, or we know we can look at offal and detect problems with animal health problems from offal. We could look you imagine a robot that goes around an orchard that tracks and looks at things at a much closer detail. Where you've got disease, we could do a lot of disease detection. There's a whole lot of things that we could do. It's a very, very versatile technology. So that's one scale. We could get even further down the scale. That's the same thing based in a lab where we could look at individual plants. So why would we want to do that? Well, so at the university, for example, we might want to do some response experiments to fertilizer. Now, previously, what we've had to do is you set up a fairly complicated trial. Every time you want to measure something, you have to cut it, you have to destroy a certain proportion of your measurements, because you can only do it once. With this type of technology, you don't have to do that. You can simplify things a lot more. So things like people like plant breeders, this could make this type of technology, and there's already a number of them working on it around the world, this could make a huge difference to them as well. So it's not just on farm. This type of technology will be used for plant breeders and a lot of other people as well. Okay, so I think that's about all I wanted to say, and hopefully I've stimulated you enough to ask a few questions. I think we've got plenty of time. Okay.
Yeah, thanks, Ian. Plenty of time for questions and discussion, so I'll leave it open to the floor. Down the back there. Sorry,
do you see this moving to a scale where it could be potentially slung under something small like a drone, or is the equipment just too large?
At the moment it's too large, and there are some limitations. Getting into the physics of it, what we're doing is we're splitting, there's only so much energy reaches a sensor. And then you've got to split it a number of different ways. And so the level of energy that if you imagine it as in, say, channels, the amount of energy is actually very small. And the more you miniaturize that instrument, the smaller it gets, the noisier your data. So there are some that will work, not to the extent that this will, but it may be that we can improve the technology sufficiently. But we've been promised things for about 18 months now, smaller units from other companies, and they still haven't arrived. And so it may come, it will certainly get cheaper, it will get lighter, but if it will get lighter enough to use on a drone, I don't know. But then the drones are becoming heavier, you see them used for sprays and so on now, so maybe the two will meet. Yeah.
Russell.
Yeah. Weed identification, you spoke about drones and bits and pieces, but it'd be great to be able to set a drone a job spraying the weeds out, or gorse on hills or something like that. But you need identification, precision where it is applied, and even some of these weeds that have come in, you scan your property, you see you haven't got them. How are you possible to do something?
So we can certainly a lot of those weeds that you mentioned we can pick out. So we can be quite specific about gorse and rush and all those sorts of things that we can. The issue is that each pixel on that image is about a meter. So if you've got, it's a bit difficult. There are other techniques called spectral and mixing. So for example, these guys were showing me how they could find a landmine that might be about that size, or they could find an aluminium can of a Coke can that was about that size. And the reason that it was because it altered the spectral signature. It was shown up as part of the image. Now one of the things we're trying to do is work out, okay, I'd be pretty confident that if you put a Coke can on a meter square, we could find it. But could we tell the difference between a different type, one type of thistle and a next? Then I'm not sure at this stage. That's the sort of thing we need to continue to do. But we could certainly, I think, things like, can we tell thistles from grass? Well, I'd be pretty confident that yes, we could. But it obviously also depends on the size and what have you. So a meter pixel doesn't sound very much, but then once you zoom in, you see that it's a reasonable size. So yeah.
How long do you think it'll be before it's useful for fertiliser industry?
Yeah. Well, I think the plan is. I'm just trying to remember. I keep getting threatened to be shot by Ravensdown because I say how much it's going to cost and when is it going to be available. But so we've got, in the project, we've got a go, no-go point next year, about June next year is when we say, yep, this is worth it, or no, it's not worth it. And then there's quite an extension programme, I think, for about 3 years after that, so where it will be gradually rolled out, I think, to then become an offering that they'll do. So I think that's a sort of typical timetable that they're looking at, yeah.
Ready?
What's the opportunity for feed budgeting, estimating pasture mass on hill country with this technology?
Yeah, I've had a long history of doing pasture measurement, and pasture measurement is not as easy as people make out. So the problem, so if you were going and measuring, say, a crop of wheat, for example, I reckon that's a piece of cake because it's a monoculture, it's all the same, it's really easy to do. The problem that you have in terms of the two things I think are, one is that grass is a constantly changing thing. Its state of maturity is always changing. It's dry matter. I think we have a far better chance with those things. We use some drone-based technology to estimate pasture mass, and I don't think I'll be shot for saying it, but I do think they're a bit prone to error. And repeatability is a real problem. So you go out 1 week, and so a drone will tell you, it's fantastic, for example, to tell you the spatial variability. So where's your weaker areas and so on. A dairy farmer might want to come out the following week and measure again to find out, well, how much is my pasture grown? That's where I think the struggle in terms of the level of accuracy that they can provide. This technology is clearly expensive. It's whether you would do something like that, use something like that to measure your pasture mass. I don't think you would. It's a $600,000 camera, but we know where to look. We know how we can make things cheaper. We've kind of gone for some cheaper instruments to start with. We think we need something a bit more complicated. So we're kind of going from two ends of the scale. This is, if you like, the Rolls Royce, and we've tried some others that are not as good or not as complex and don't give you as much information. We found that they weren't as reliable as we'd hoped, and we're probably going to move back up that scale a little bit to get you the level of reliability. But there are other things you can do. I mean, you could do, like, use a satellite, for example. So the satellite information is getting more frequent, it's getting better quality imagery. So things like maybe late spring, looking at, where's it drying off. A satellite will tell you things like where if you're getting dry matter is increasing, it's drying off. Satellite information should tell you. Ground-based temperature will also tell you. So if it's warming up, you know that the grass is dying and what have you. So it might be too late, but what it's doing is it's giving you a spatial picture of how much of that is happening and where it's happening and so on. So there's different sources of information. I had some visitors from California about a couple of months ago, and I said to them, look, what I want is a hangar on my property that when the conditions are right, it opens up, the drones fly out, monitor what I want to monitor, come back, download all the data, and then it's all done. And they sort of looked at me, oh yeah, whatever. And then I took them to a farmer, and he said, right, what I want is a hangar on my farm that knows exactly when it's going to go and measure, goes out, does it, comes back, downloads the data, and I can get the data on my phone. And that's, I think, where we've got to go. That there's got to be still a lot more automation. It's not for everybody that wants to fly drones and what have you. And I think that technology has changed a lot in sort of four or 5 years that we've been using drones. It's changed hugely. They've got much better, the level of control, the automation, and so on. So again, I just think keep an eye on all these sorts of things that are happening, not just what we're doing. So a bit of a long-winded answer.
Oh, well done. I think obviously there's been a bit of work done. That's cool. And that thing seems to be pretty impressive. So suggesting it just about to see my wife changing her mind. But I was wondering if it could see if you could detect groundwater. What's the opportunity below the surface?
It's really only, it will see the first surface that it comes to. It doesn't have enough energy to penetrate anything. It's just really looking at the light that's coming back up off a target. But in saying that, things like lakes, there's a lot of work being done around the world, looking at things like, so if, say in Taranaki, you might want to fly it over some oil rigs. Is there any spills? You could easily detect that. Pollution in water, levels in nitrates in water, turbidity, all of those sorts of things you could do on, most of what I've seen it's on lakes, but and some in sea, but you could do that type of thing, yeah.
A little bit. Previous question, does the definition increase with a drop in altitude of the flyby?
Yes. Yep. So if you want to get, so that when you see it in the lab, each pixel is about 1 millimeter. So when it's about 0.8 of a meter off the ground, so I can take an image of I think it will generate something ridiculous like 450 million data points over a square meter. And there'll be each point, so you imagine in a plant, so I'm wanting to see what a plant's, say, responding to a nutrient or something like that, or a disease, then each square millimeter of that I've got measurements. So yeah, you just drop down but they're also put another one up that's got a similar performance if you fly twice as high. So it will have a similar resolution, so you could fly it the way that, so we fly at 2,000 feet because we think that's a good compromise between the level of information that we need and the speed. So we can do up to about, I think it's about 1,000 hectares an hour, something like that. It might be a wee bit more. But there's another instrument that's out of the same stable that you can fly twice as high, twice as wide, and you cover the ground much faster. So, but yeah, you could bring it down. You could use that one at the same height and get double the definition or double the resolution. Yeah.
How do you eliminate the changes in environmental variables like soil moisture and temperature that can also influence the productivity?
Yep. So when we're measuring through the atmosphere, so we're up at 2,000 feet and we're measuring on the ground surface. So changes in light and shadow, moisture levels, all of those things have got to be taken account of. And so even before we start to process the information in terms of the spectral information, there's about 10 different steps that we use to make sure. So if you like, we're trying to put it onto a three-dimensional land map of the farm, if you like, for want of a better word. But we take out any distortions, we look at atmospheric correction, we look at trying to attempt to recognize where there's shadow, all of those types of things. If the moisture, there's part of those curves, you saw there's two dips in it, that's associated with moisture. So again, we know what's going on there. So if you're looking at water bodies or very wet soil, that would probably show up if it's really wet, if there's not too much ground cover. But remember, it's looking at the surface of what you're looking at. So
does it influence the accuracy of your estimation?
Well, it obviously will, because so the best way that I could possibly get a measurement would be to go and take a sample, dry it, grind it, put it in, and use that machine and compare it to a lab thing. So if I take a sensor and then I just take a reading, say, from a whole grass plant, and obviously the architecture of the grass and as it matures and what have you is going to have an effect. So it's going to make the data slightly noisier. If I'm looking through an atmosphere of, say, 2,000 feet, it's not going to have a huge, well, it can have a big effect, but there's, as I say, there's about 10 steps that we can take to work out what is the difference, what are the differences in lighting conditions. We also have targets on the ground that we use continually, so things like roads or roofs, or if we know on an image, and we can then, something that doesn't change, then we can look at those and then use those to evaluate, is the image actually true and correct. So there's a lot of different things that you can do to try and eliminate error as much as possible. Yeah.
So one more question.
Mhm.
If you've got limitation penetration of this waste, how do you measure the nutrient level in a soil with 75 millimeter?
Yep. We're not measuring the soil. What we're doing is measuring the plant and looking at the association between the plant and the soil. So what we are doing is, while we're that diagram that I showed you with all the farm with all the green dots on it, those are sites where we're using calibration measurements to take measurements of the vegetation and measurements of the soil. So that's what we're using as part of our calibration process. So I think we have something, it might be 7,000-8,000 measurements now to look at the comparison.
Yeah, does that lead on to potentially using differences in plant relative differences in plants to assessing on-site soil type? Could you break that association?
Yeah, we've already had a few people asking us around some, where there are different soil types and different types of vegetation that are kind of grown as a result of that. So that's something that we've still to investigate. But yeah, I would imagine so. Things like you could draw kind of inference from the fact that there's a different type of vegetation in that area compared to this area over here.
Another one at the back.
Coming back to the variable rate hopper,
Mhm.
you've got to say that it actually takes into account the different topography, and I'm thinking in terms of how high above the ground the plane is flying, and maybe also the angle. Would you want to put as much on a hen's face?
No. So we've got, if you like, there's a model, we call it a ballistic model. And what it does is it can describe how the fertilizer comes out of the plane. So what you'll find is that as the plane's coming along, okay, it goes in front slightly, but then gravity takes over, and it might be still slightly in front or moving slightly forward, but it's getting pretty close to vertical. So the trick, what we're trying to do is, this is the boundary. When do you switch off the hopper? So that's the sort of thing we're doing. We're not trying to, so what we would do is, if say you're coming up a hill, or you're going up and you're slowing down, it would be the fact that it's slowing down that would dictate the hopper door opening. It wouldn't be the angle of the plane that would dictate, it would be the fact that you're slowing down.
So the higher you are, the sooner it shuts off the gate and it's coming to a down.
Yep. Yeah, again, there is a slight difference, and I'm trying to remember if it does take differences in altitude off the ground into account or not. I can't remember off the top of my head, but it may not actually. But I'm not sure. It may do, but it's got. I mean, all these systems, like most of the top dressing aircraft in the country have pretty good high quality GPS in them. They're updated 5 times a second, so they have a fair bit of information there. So yeah, I'll check up and find out for you.
Any more questions? Good discussion there.
Yeah, got all of those, taken all those thermal images of the different levels of nutrients, and then but when the plane flies, you've got one mix of fertiliser in the plane, so you're going to have to make a lot of compromises to get the right mix for that farm, so because you can only alter the rate of the fert that's coming out of the plane, not the rate of the different nutrients there are.
No, I understand that. Yeah, so I mean, again, it's a question of trying to work out what's the best form of fertiliser that you would put in that would get you as close to meeting your needs as you can. Yeah, we're not well, I don't know, I mean, it's up to Ravensdown, but we've done a lot of work in from top dressing aircraft, looking at blended fertilisers and so on, and generally it's not a fantastic idea to try and blend a whole lot of different nutrients in the hopper, or pre-mix, you know, because there can be problems.
Just to change tack, instead about being in the meat processors, so could it take over the people that are doing the beef EQ thing?
Well, yeah, potentially. But as I say, it's probably just at that idea stage and the experimental stage. But we know that we can detect, say, problems in the offal. One of the projects we've looked at, well, we know we can tell the difference between lamb meat from a male lamb and a female lamb. So we can detect differences in quality, and we've looked at some where we knew there was some disease present, and we were able to recognise every carcass that came through that had been pointed out that there was a disease, we were able to identify. We kind of did it blind, but we were able to identify them just by looking at the offal. So that might be a way, you know, when it comes into the meatworks, whether it's RFID, that you just link it in, and then you link it to the carcass and pull it apart for or pull it to one side for inspection. But I don't know, maybe you can do it with the carcass, but also one of the challenges is doing it real time, so that in a meatworks you're going to have to do things. It's going to have to be, you know, done real time, and that's still a bit of a challenge for some of this type of technology.
Cool. And lucky last question, if there's one ready to go.
How reliant is it on having a still image could be potentially used, for instance, to take different animals? So you potentially fly over once a year and do a stop day.
Yep. We know, I was just messing around one day, and I know that a sheep has a different spectral signature to a cow, obviously, or different cows, so probably different breeds. Yeah, I think you could do all that type of thing. I mean, it sounds a bit bizarre to do it or say it, but yeah, you could easily pick out, like say, certainly different breeds of cows and those sorts of things you'd be able to pick out, no problem. Yep. Count them, yeah, just get the software to count them, yeah. I mean, that's been done already just for some of these other systems that, you know, can count, yeah. All right.
Oh, well, thank you very much, Ian. That's fascinating and enlightening, and very, very good. Thank you.
Well, thanks for the opportunity. I'm very delighted to be here and talk to you. Thanks for the invitation. So we had this morning we had a series of interesting talks on different topics related to water, energy, and food. And most of those talk about more in general at the state level, at the national level. So what I'm going to talk to you is about some of the new technology that are coming or currently available at the farm level. And talk about how those technology can help us to save these resources and utilize these resources much better. So this is something we kind of discussed this morning about, can we feed the world? As you know, that by 2050 we need to increase our food productions. We had an additional 2.3 billion people, and that increases the amount of food that we need to produce. Water shortage is a topic that discussed this morning. Farmers need more water. In fact, while we are still have a problem using existing water, we need more water by 2030 to meet the demands. Also, at the same time, we are losing land to urbanization and a spread of plant and animal diseases. This is another issue, and I'm going to touch on that a little bit during my talk. So what we really need is, of course, we have to increase our production while we're maintaining a sustainable production system, and try to reach to the potential yield of this. So these are, if you look at the FAO, these are the things you see in the expectation that what's going to happen. At the same time, we heard about, like Dr. Porter this morning mentioned about the LEDs technology and so how human ingenuity can change all these predictions, and we've turned out that we may be wrong on all these predictions. And so during what I'm going to show you that now is that some of this new technology that's coming up in the production side that has a lot of potential for making those changes. So at the farm level, I think that we can increase innovation in agriculture is currently happening in four main categories, in my view. One is cost-effective rugged sensors for collecting data in the field. So the way the current technologies go is that it's mainly data-driven, and that's what we are trying to do, is to talk about collecting more information and increase our efficiency using information-based management techniques. Then we also have the semi and fully automated autonomous ground and aerial vehicle. I'm going to talk a little bit about that and how it's going to affect the productions. Innovative data communications and hardware and software to utilize those data to make it into better management decisions and help the grower to make a better production. And at the end, innovative environmentally friendly practices that is resulted as those new technologies. So, one of the things that we hear, I'm going to start with the machines, tractors, equipment in the field, and talk a little bit about that and explain what's the new technology coming and how that affect all these things. So, you know, manufacturer, right, consistently working on improving their equipment. They're improving their machine, increasing the fuel efficiency, decreasing the pollution, and decreasing the breakdowns of those machines. But among those technologies that are coming up, one technology specifically, in my view, is making a very, very important changes, and that's what we call it a CAN bus. So what is CAN bus? CAN is basically inside the tractors. There are several computers. In fact, tractors are more complicated than most people think. There are several computers that control the engines, control the transmissions, and control the other steering system and also the implements. So this CAN system is a communication protocol that allows these different computers start to talk to each other at the same time. So with this standard bus, now every time you connect a tractor to an implement, the tractor automatically recognizes what implement is connected to it and try to adjust its settings that is most appropriate for it. For example, so if you connecting a planter to your equipment, it quickly recognizes what kind of planter it is, what's the setting is, and start to doing very interesting things with it. For example, in the past, when you are planting and you are turning a curve, you are putting the same amount of seed, but the planter, the unit that is far out to the curve, it should put more because it cover more ground. So this new system now, it recognizes that and try to compensate for it. So it means that you have a better uniformity in your system. But this is not just limiting to that. It also brought up a very, very interesting new thing, and I just heard about it, that a lot of time now, the implement control the tractor. Not currently the other way. The tractor pulls the implement, and it goes with whatever speed they want. Now in the future, the implement actually, and this is not the future, it's currently new planter has the capability, that they can control the tractor. Means tell the tractor how fast I want you to go. So tractor is basically follow the order of the planter. So if you are plowing, for example, so it measures the forces on the on the moldboard plow and decide how fast it has to go so that it does the best job while we're doing this. So this kind of technology is very interesting. At the same time, and it collects all those information. It tells you how fast, what's the engine's RPM is, how fast it goes, where it is in the field, how many seed per acre it puts. And all this data is not going to be stored or disregarded. All this data actually goes to a central location that farmers have access to it, dealers have access to it, and they can determine if this tractor is utilized correctly or at optimal productivity. At the same time, if, for example, the amount of seed is reducing in the bin, it triggers a signal to another person that bring more seed. I'm going to run out of this. Meet me at this point in the field. So all these things, it enable us to do a more efficient job, and that's what's right now happening at the field and at the machinery level. So the machines are becoming a lot more smarter, and they are increasing our efficiency of that. And so that this could result in better yield and improve our yield and also improve our resources. So another example is a auto steering system. Because they are so accurate, these are the system that steer the tractor in the field in a series of parallel line, and because the accuracy is about half an inch or so, so the guess rows are very accurate. In the past, guess rows could be, a lot of variability there. Now with this technology, they are very, very accurate. So the point I want to make is that data is going to play an important role in increasing the efficiency of the equipment. This is the slide that I borrowed from our colleagues. It shows the flow of information from field to product. So let's start with the first one that says on field management. So the first step when we are trying to plant is to prepare the soil, right? So we need to have information about the soil. We need to know the variability of soil, physical and chemical properties, how much nitrogen, and a spatial variability, how much nitrogen, phosphorus, potassium, soil organic matter, and so on is there. So there are sensors and equipments that is available right now or at the production right now that enable us to collect all this information. We know variability in soil type. We know which part is compacted or not. The next step is planting, and again, these sensors enable us to collect information about field records, what kind of irrigation system we use, how much fertilizer we put in the field, how many material we sprayed, at what location, at what concentrations, size, color, etc. And then when we get to harvesting, again, we know how much yield we have, and even information about the quality of the material we harvested. And then it goes to the post-harvest. It means the grading. So if for example, if we are harvesting fruit, we can now see what was the average size, what was the quality, what was the sugar content, what was the acidity, and so on. And at the same time, all this information at the production level can then go along with at the distribution level, and then it can go at the consumption level. So the consumer now can get all this information. And so all this information can be useful. So I'm going to go through some of this technology and explain a little bit, and then show you how they can be very beneficial to us. So I'm starting with the yield monitor because this was the first probably sensors that was developed back in late 80s. Engineer does design this mass flow sensor that they put on a grain combine, and they were able to actually quantify the amount of grain that goes through the combine harvester as they go through the field. And they were able to create a map, and combining that with the GPS, they were able to combine that and create a map. We call it the yield map. So yield map was a very interesting map when we first created it. Not that farmer didn't know about it. Farmers always knew that there is a yield variability in the field. One thing they didn't know was that what's the extent, and they never quantified that. Now, yield monitor was able to quantify the amount of yield variability, which was very exciting back then. But then it causes an issue which says, okay, that's interesting to know that I have a high yield here and low yield there, but the question is, what causes it and what can I do about it? And that turns out to be a more challenging question, because in order to understand what causes it, then you have to have more data, more information, and understanding why yield is low here. Is that enough nutrient there? Was there enough moisture there? And so on. Was there seed there at all? That was one issue with the yield monitoring when it started. The second one is that you get this yield data after season is over. It means it's good information, but season already over and I can't do anything about it. So what we really want, we want something that can tell us about this early in the season, because the cause of yield variability, there are two types, either manageable or is not manageable. So if it's a manageable, then we would like to do something about it. And that's where the yield estimation came. And it turns out that yield estimation is actually more useful for growers in terms of, if I can predict what the yield is going to be, it's really helpful, because if I can understand what the causes of it, I can do something about it. So what's happening right now is that we have lots of good crop models. There are lots of good crop models that, if you know the given environmental factor, it can predict the yield fairly good, especially for certain, like a wheat or for corn and no. So now that we have a yield monitor, what we really need is to have a good way of measuring all those environmental factors. If we have all the input that goes to that model, if we can measure it at the field level, at a larger scale, then we can predict the yield fairly good, and then we can see if we can do something about it. So that requires that we have more sensor. And that's what we get. We need soil sensor. We need sensors that can measure soil moisture content. And it's not just a one-point measurement. We need to, if you have a 10,000 acre, you need to imagine how many sensors or what you need to have in order to calculate all those variability in the soil. And also all other things. And agriculture is complicated. It's not just one factor. It's a series of factors that sometimes very hard to measure. So there has been a lot of work on developing soil sensors and sensors that can measure factors related to the soil. At the same time, there were some sensors that measure factors related to the plant, disease, nutrient deficiency, and so on. And all this, a lot of these sensors are optical sensors, means they are measuring spectral characteristic of plant, and then try to relate that to what could cause that change in the spectral characteristic, and from that figure out what's going on. So for example, this one is like an imaging sensor. This is what you start to see a lot more and hear about it. These are the these are the cameras, the special cameras. Like you can see, there are 6 lenses in front, and there is a filter in front of it. So this particular one, we were using it for detecting citrus screening. It's a disease for citrus. So we find out, for example, what is the spectral characteristics of the citrus screening, and then we try to narrow it down to certain bands. And then we selected filters. The filters only allow a specific band can go through it. And then, so this filter, we put it in front of camera, and then using those 6 bands, we were able to see if we can detect the greening. So this is also applied for other crops and for other diseases as well. But the concept is this, basically. Other kind of sensors are sensors that measure canopy size, volume, and density. And as I said, there's this example that here is the laser that measures the canopy tree size, volume, and we were trying to use that. For example, for tree crops, the amount of nutrient is proportional to the size of a tree. So if you have a larger tree, you need to put more. If you have a smaller, you need to put less fertilizer. So if we can somehow measure it, then we can somehow automate this system and make the fertilizer spreader more more smart, putting the right amount at the right location. And then there are a new group of sensors that come in that call it biomarker-based detection. And these are based on the, they are looking at the special, like an artificial nose. It's just try to detect a specific chemical that released as a result of the insect or disease. And if they can detect that at the very low concentration, they can relate that to that specific disease and figure out what it is. So all these sensors also need some sort of a platform. And you will see that there are a lot of innovation is happening at this level. So for example, what you see here, the black box, look, a black box is actually a robot we are building it for strawberry. So this supposed to go on top of a strawberry rose and look for a sign of disease and try to detect the yield, basically estimate the yield and detect the any diseases. And this is, again, is a project in progress. But we also have two other things that happening. Is a autonomous ground-based vehicle, which tractor could be also one of them, and then aerial ground-based system. So I'm going to start with the ground-based system. So this video, as you can see, this is about 15 years old video. And it shows that John Deere built this autonomous tractor back in 2000. So they had already this technology that they were able to actually go through the rows. So you don't need any operator, it goes through the field. Then back in 2008, we also got a grant with John Deere and Carnegie Mellon and so on, to try to build a series of the tractor that collaboratively work together and do the actual field operation. This particular, there is a person sitting on it that actually the tractor is autonomous. Just to safety, we need to put somebody there. So this project is went ahead, and in fact, from the technology point of view, John Deere already have the capability to build autonomous tractor that can do all the field operation. So there are advantages to have. Why do we need autonomous tractor? Because tractor can work 24 hours for you. Then you don't need an operator, and it can do spray at night, because spraying at night is a lot better than spraying during the day. So there are a lot of advantage of having an autonomous tractor. But why don't we see that? And in fact, at the end of this, still John Deere doesn't want to market this, although they have the technology. So why they don't want to do that? Because of liability. I mean, they are concerned that in case something goes wrong, they don't want to be liable. So last month, I heard about this. A small unknown company called Autonomous Tractor Corporation in North Dakota, for the first time marketed the first autonomous tractor in the market. You can actually go and buy this tractor, fully autonomous. There's interesting features about this tractor. They're building tractors about 100 to 400 horsepower tractor. They have their own navigation system, and they are start selling these tractors. Well, it sounds like this company may not be so concerned about liability because it's such a small company, and they may be able to pull this off. But the advantage of a company like this to market something like that is that they kind of force the other manufacturer to come to the market as well. And interestingly, the price of this is not much higher than a regular tractor. So a 100 horsepower tractor, autonomous horse tractor, 100 horsepower autonomous tractor costs around $50,000, which is in a ballpark of similar tractor at 100 horsepower. And plus a lot of interesting other features that comes with this. So this is an example of a technology that can potentially changes the way we operate and utilize equipment in the field. Another interesting topic that is, you start to hear a lot about it recently, is the small unmanned vehicle. And the reason for this is that, as you probably heard, the FAA is going to open U.S. airspace to commercial use of a small UAV. And it turns out that agriculture is going to be the biggest market for this And as a result of that, there is a huge number of companies that start building these small UAVs for use in agriculture. We started working with this back in 2005, 2008, 9, because that was the time we had the greening problem in Florida, and we were trying to find, back then we were trying to detect the disease. So that disease is much easier to detect from the air. If you look at the symptoms are easier to see from the air. So we were trying to use that. And while we got into it from the disease point of view, we start to see that there are interesting use for this. And so this is a fixed wing. Probably you start to see a video that shows, these are fairly low cost. They can, throw it by hand and take an aerial image of your field. So these are, as you can see, the orange grove in Florida, and we were collecting data for a different purpose. So it goes, it flies over, as I said, with the autonomous. There will be a pilot sitting there, just basically watching it, and it will take over in case there is a problem. But as you see, it just fly on its own on a predetermined path. It just go back and forth and take aerial image. What's the use of it, and why we think this is such interesting technology? Because there are a lot of things we can do with this. Not that we couldn't do this before. We could have always used this technology using satellite or manned airplane. The problem was that the cost. Back then it was, still it costs a lot to have a manned airplane to fly and collect those information, whereas small UAV costs very little. And plus, you have the chance to do it when you want to do it. And a lot of time in agriculture, we have a small window of opportunity that we need to fly at a very short time, and this allows us to do that. So the use of this, what can be used for, we divided this to two categories, active and passive. So passive is using it for disease and stress detection, monitoring crop growth, yield estimation, assessing herbicide efficiency, optimizing nutrient, water management. And an active one is chasing bird. This one is for blueberry growers. That's what they like to do. They think that's a useful application for it, or chemical applications. So again, some of these things are nothing new. Remote sensing been around for a long time, but one thing that the UAV allows us to do is to collect image at a very, very high resolution. And the high resolution means a lot in disease detection for tree crops. So this one, the one you see on the left is a false color. What you see as red is actually near infrared. So our eyes really cannot see that. That's why they use a red on that. And then we can calculate the NDVI, which is a vegetative index. And that will tell us something about the stress in the tree. So what you see as a darker green is actually healthier canopy, and the trees that are declining are less green. Plus, you can also quantify the weed between these, and those are other applications. Okay, as I said, all these things have been around, and it's not really new technology. But what is going to change is that what's really valuable for growers is if we can do something with this that they cannot do it on their own. So, for example, this is about 100 plants in this. 12 of them are water stressed, slightly water stressed. And if you show this to anybody, there's no way they can tell you which one are water stressed. But if you take a thermal image, then you can see those 12 shows up. And these are the value of this technology, that it enables you to do things that human cannot do. And that's where they're really valuable for growers. Another application is inventory management, being able to know how many. This is actually a Christmas tree field this is in Oregon, and the growers wants to know how many trees they have. And interesting, if they don't even know how many trees they have, they just plant and they want to know how many trees they have and what is the probably quality of that. This is another field. It's inventory management in open field nursery. This is interesting because this is a big problem for nursery growers. Is that they put these pots and they grow them, and first they put in a row and column. So it's very easy to count at the beginning. But then they partially harvest, means they remove the good ones, and then they end up having something like this. There is half of it gone, and now if you try to count this, it's very difficult. And to send somebody to count this, it takes time, and it's very time consuming, whereas you can do this from air. Just take an aerial image and have a software to do this. Even we developed a software that can actually count overlapping canopy, which means with the overlapping canopy, in fact, human cannot count. So that's another advantage, that you can do something that human cannot do. This one is an example of the system for pest insect detection and insect pest pressure mapping. This was a quick test. We were trying to see if we can really detect psyllid with the aerial image. So as you can see, it flies over and takes images from these sticky traps. And then you can see that as it flies, it takes pictures. You can see the pictures on it. These are very high resolution pictures. So you can actually zoom in and see very details on it. Unfortunately, these psyllid are so small. It's like 2 millimeter length. So very hard even with the high resolution to count on it. But what we were able to do is that we were able to actually create a map and show that there is a border effect. That's something that entomologists always told us, that this comes from the border, and there is high concentration is around the border, and in fact we saw the same thing. And so what can be used is this type of map is that you can use it to actually do your sprayer based on that. So if you get more psyllid around the border, you can spray them more often than the center part. But here is the other interesting things that, as I said, this technology evolved. You can do very interesting things. One of them is that there are software that are commercially available that allow you to take a 2D image and convert it to a 3D image because the way you fly and take consecutive pictures. So this is actually Orange Grove that you can see. We can see the size and volume of the trees here. So what's the use of it? What's good to know that what's the size and volume? Well, this has a very direct use for yield estimation. In citrus tree, the larger the trees, you get more yield. So having also a map of variability also very useful. Another one is for research. This is a nematode in a strawberry field, and we had colleagues who were trying to study some chemicals alternative to methyl bromide. As you know, methyl bromide is phased out, and they are looking for alternative to it. And they were doing these plots. They're putting different concentration of different chemical, and they're trying to see which one is more effective. Well, it's a lot of labor to go and quantify that from the ground base, but from the air is much easier and faster to do. But this is a new thing. I was in Germany 2 weeks ago attending a trade show, and this, as I expected, there was a bunch of companies who offer UAV, but this one was a UAV that has a gadget underneath, and I was curious to see what it is. It turns out that this was actually a drop release device that attached to a multi-rotor UAV for biological control of corn borer. So they dropped these pallets that has this wasp, which is a natural enemy of that corn borer. And they try to use the biological control for that. And they are using UAV to do that. So there are a lot of more examples of the UAV in agriculture. But and I don't want to go through all of them, but you start to hear a lot more about it. But one thing I want to say is that with all this new technology, then we introduce in technology to the growers, and they take it to the innovative growers, take it to a very next level. For example, this is an auto steering system. It's been in the market for the last 15 years or so. This is a picture from a very innovative growers in Iowa that he used this technology. So auto steering is basically steer the tractor in a straight line throughout the field and allow you to do these operations. But he started to use it in a very, very interesting way. One of them was, we had something called a strip till. It means you tilt the field in a very narrow strip in fall, and then in spring you go back and plant right on the top of the places that you tilt. Well, without the auto steering technology, this was a very, very difficult part because you could not figure out where was those tilt bands. But with the auto steering system, it's very easy, and you can go back and tilt on this. So the advantage of this is that you save a lot of energy because you only tilt a narrow band, not the whole field. And this is very common now in Europe. They are using this a lot. Other one is a concept of, they call it controlled traffic. The idea was that you only drive on a certain path through the field so that you don't compact the soil, so that you don't reduce your yield. So the idea was that you select your map, your implement, so that they always go on the same path. So, for example, you're spraying, you're planting, you're spraying, and then your harvest. They all go on the same path. Again, this technology would not be possible without auto steering technology. But now you can do this with auto steering very easily. This is another example. The inter-row planting of corn and soybean. They usually have a rotation of corn and soybean in the Midwest. This idea is that they just do a band of corn, a band of soybean, and then they change that. What's the advantage of it is that the corn, the boundary one, because they get more sunlight, you get more yield. So this way you can get a lot more yield if you use this kind of technology. Again, this required that you have to drive it very, very accurately, and that it's not possible without other steering technology. Another thing, and this is something we are doing, a heat treatment. This is a machine that we use to treat the HLB-infected trees, not completely treat them, but to kill the bacteria. So we cover the tree, we inject the steam, and so on. So what I'm trying to get with this is that a lot of time we are focused on chemical control, and we totally ignored physical control. Now this technology allows us now to look at the physical control by changing the physical condition. Like imagine if you spray a leaf with certain material that it's so slippery that insect cannot sit on it, they slip, then they can eat on it, right? So these are the new concept that is evolving and coming into the market. So to conclude my talk, I just want to say that we can always improve our efficiency of our operations in the field, and the technology can really help us to do that. There's economical, environmental, and logical reason for that, and information-based management technique is really can help us to reach that goal. Obviously, economics of it need to be considered, because that's always the factor that growers ask. Anytime you come up with a new technology, they ask you how much. I mean, and that's one thing we also need to think about that. There are opportunity for us in terms of using the information for managing decision, and the good thing is that this kind of technology, especially the one I mentioned about UAV, and any kind of growers can benefit from it. This small or large growers, they can benefit from it. And of course, there are challenges that every time we build a sensor, we are dealing with the fact that it has to be robust, it has to be reliable, at the same time should be cheap. They want them all, and that's not always possible. With this, I just thought to conclude my talk, and I'll open up for any question you might have.
Good afternoon. My name is Henry Neufeld. I'm head of the Climate Change Unit at the World Agroforestry Center, ICRAF, in Nairobi, in Kenya. And I welcome you very much to this discussion forum organized by ICRAF together with FAO. And while we start going through a quick round of introductions, I hope that there will be more people coming in, and so that we take as much time as we can for discussions afterwards. The title of this session is called Using Climate Smart Technologies to Scale Up Climate Smart Agriculture, and forget the practices, it's a bit of a tautology, and I apologize. Climate Smart Agriculture has had quite a bit of a, let's say, it's been a very shiny kind of brand coming up. It's managed to unite sort of the development, the agriculture, and the climate change communities under one brand. And in doing so, it's raised a lot of expectations. The term has been around for about 4 or 5 years. There are a couple of publications that have been put forward around climate smart agriculture, what it really is, what it could be, and still we still do lack a bit of an understanding of what it could actually do. And this session here is also meant to shed a bit of light on that question. There has been a global alliance for climate smart agriculture, which was launched recently at the Climate Change Summit in September in New York. There's also an African Alliance for Climate Smart Agriculture, and we will also talk about these two new institutions and what they can potentially deliver in resolving issues around food security, adaptation, and mitigation. So let me just quickly introduce our speakers. First, we have Alexandre Maybeck, who is a Senior Policy Officer on Agriculture, Environment, and Climate Change in the Office of the Assistant Director General within the FAO. Then our second keynote speaker is Todd Rosenstock, who is an agroecologist with ICRAF, and he investigates how smallholder agriculture affects the environment and society. And then we have panelists here sitting next to me. We have here, sorry, where is she? Hlami, I'm sorry, I can't get the name right. Ngwenya, I think. She's a manager for communications and knowledge at FANARPAN, the Food, Agriculture, and Natural Resources Policy Analysis Network, with 21 years of experience in policy research and advocacy. Then we have Martin Bwalia. He's the head of the Comprehensive Africa Agriculture Development Program, CADAP, within NIPAD. And finally, last but not least, Austin Tibu. He's been working as a land resources conservation officer at Malawi's Ministry of Agriculture, Irrigation, and Water for over 10 years, and he's also the FAO focal point for economics and policy innovations for CSA in the EPIC program. And then we will have Richie Ahuja, who's sitting here in front. He is an expert in business development strategies and spearheads the Environmental Defense Fund's engagement in Asia. He will be rapporteuring. He will give us a short summary at the end of the session. So without losing any more time, I'm going to ask Alexandre to say a few words about what climate smart agriculture is, some backgrounds, opportunities, and challenges. And then we'll hear what Todd has to say about climate smart agriculture, a panacea or propaganda. Okay, please, Alexandre.
Thank you very much. And yeah, I move that. Yeah. Yep. So I will very briefly introduce or reintroduce, for those of you who already know what climate smart agriculture is, what the way we understand climate smart agriculture in FAO, which can be slightly different from some of the things that are around more and more. and just extremely briefly giving examples, because examples is probably the best way to understand what climate-smart agriculture could mean. So once again, agriculture has to address a triple challenge: more food in quantity, quality, and diversity everywhere for everyone, adapt to climate change, and contribute to mitigate climate change. The important point, I think, is that this triple challenge has to be seen at various scales: global, local, and household. And we always need to keep in mind these various scales when you look at systems and what can be their contributions to climate-smart agriculture. Growing demand all over the world, due also to diet changes, but especially in some countries, and many of these countries which are already food insecure and which will be the most affected by climate change. And globally, worldwide, FAO estimates that production has to increase by 60%. Very briefly, main effects of climate change on agricultural production: a decrease of production in certain areas, a change in the geography of production between countries and inside countries, and also and especially an increased variability of production. So the impacts on food and nutrition security have been well described in the HLP report 2012 and now in the IPCC report recently released, with impacts on the most vulnerable countries and the most vulnerable people, mainly, and with impacts on food security and nutrition, which are much more than just decreasing yields. Decreasing yields and the consequences of decreasing yields, changes of the geography of production, and so vulnerable countries having to import, and price volatility, and the combination of all these effects. So agriculture can also contribute to mitigate, and the way we see it in FAO, given the fact that agriculture has to produce more, is to understand mitigation as a reduction of emissions per kilo of output. Globally, having emissions increasing less than production, and also enhanced agricultural soil carbon sinks, which means sinks above and underground. So the concept has first been introduced in 2010. It's with the title of a brochure that FAO prepared for the Hague conference. So it's amazing how the word is now all over the place, probably because this idea that we need to address various objectives at farm level, at country level, and globally is really needed. And also, one other important point about the climate-smart agriculture approach is that it is not only practices or systems, but also systems from an agronomic point of view, but also the policies and institutions and the finance which are necessary to enable these changes. So it's really the three of them. To a certain extent, why climate-smart, I don't know what is a climate-smart technology. I'd rather think about climate-smart systems. And when you try to take these three objectives together, food security, adaptation, and mitigation, globally what we want to do is more resource-efficient systems and more resilient systems. But be also careful to what we want to mean by resource-efficient systems. It's not only more crop per drop, it's also more income per drop, more jobs per drop in the countries where agriculture is the main source of jobs and income for the population. Which means that it is very country, local, system specific, the way you imagine the technologies and the way they are integrated in a system. And globally, what we think is that the trade-offs are not really between food security and mitigation or food security and adaptation, but rather between increasing resource efficiency and increasing resilience. And this is where you have to look at trade-offs and synergies. An important point, which is why I was insisting on the various levels in the system, is that we need to increase the general resilience of food systems, which means the physical resilience, environmental, but also the economic and social resilience of the system. One of these dimensions being able to compensate for a certain time, but not for a very long time. But for instance, social protection can help farmers resist a physical shock, avoid them selling all their livestock, for instance, and enable them to recover afterwards. But resilience has also to be seen at various levels, each level being able to compensate for another. The resilience of a household depends on the fact, also on the fact that they're diversified sources of income, but also it can be compensated by social protection, for instance. Trade can play a role to a certain extent, provided that there is income. So that's why we were insisting on the need to understand how the various systems relate one to another. Household to the farm to the landscape, the farm to the food chain, and all of that constitutes various food systems. So really very, very quickly, and you'll hear much more about it after me, understanding climate-smart agriculture has to be done on the ground, in the field, in real systems. So these are just examples of a brochure you'll find downstairs, where we tried to look at the various dimensions of the impact of a technique. In other words, and to come back to the title of my presentation, we believe that there are opportunities to have climate-smart systems, more efficient and more resilient. But the challenge is to be able to properly measure the various impacts of the techniques, both environmentally, economically, and socially, and in various time frames. And these are very different according to the system. It's not the same if you introduce urea deep placement in Bangladesh, where jobs are very low cost and you need more jobs, and in China, for instance, where labor is much more costly, so you need mechanized systems, and the impact on food security will be totally different in the various systems. And very often what happens is that, which is where climate-smart agriculture makes the change, we've introduced a technology for a precise objective, and we measure that precise objective. We have the baseline on water, and we measure how water is used. Very often, we don't have the impact on economics, on livelihoods, on income, on social issues, on gender sensitivity, etc. So these are some cases where we have them. Sustainable grazing for better livelihoods in China. This is an interesting project because in the beginning, it was introduced as a mitigation project to increase carbon sinks. But in fact, it is totally transforming the systems and the livelihood of the people, and it's much more a food security and an adaptation project with a carbon finance component, but it is this carbon finance component which began triggering the institutional changes. You'll hear probably more about these ones afterward. Insisting also on the importance of genetic diversity, just as an example of things that we need in order to be able to react to uncertainties. And this is another very important dimension of climate-smart agriculture. When we say increasing resilience, we mean resilience to everything, because we do not know exactly what are going to be the changes in 30 or 40 years in whatever area. Landscape approach is also a key one. I've already mentioned that one, and I will stop here to leave the floor to my colleague. Thank you.
So what I'm going to be talking about today is trying to answer... Ooh, it's cut off. Hopefully not all of the slides are like that. What I'll be talking about today is trying to answer this simple or somewhat complicated question: climate-smart agriculture, propaganda, or panacea? And here, and like this title slide, this question is incredibly complicated, especially for climate-smart agriculture. Because with climate-smart agriculture, what we're talking about in many cases is multiple dimensions. We're talking about multiple practices. Here you can see it's agroforestry, intercropping, conservation agriculture, improved cook stoves, as well as multiple outcomes. So we're looking at nutrition security, we're looking at poverty alleviation, we're looking at natural resource management. And so how do we even begin to think about and begin to analyze this type of complexity? I would contend that it's this type of complexity that has largely made helped spur the debate about whether or not climate-smart agriculture can actually achieve some of its ambitions. And it's because of this we need to pull back from some of the sort of idiosyncratic case studies and try to get to the real big issues that we can then start to bring these topics to scale. So over the next about 10 minutes or so, I'm going to be telling you about the initial results from a meta-analysis that we've been conducting about specifically to try to answer the question of how do farm management practices affect food security, adaptive capacity, and mitigation. And so I was sort of inspired to take on this topic largely because I was seeing things like this in the news. The Global Alliance for CSA wants to reach 500 million smallholder farming households. The African CSA Alliance and the NEPAD Vision 25 by 25 want to reach 25 million households by 2025. This type of effort will require a Herculean change in how we as scientists and we as development practitioners actually implement agricultural development. And so, but the real question here is, what is the evidence base? All of this type of development initiatives is fundamentally based on the assumption that we have evidence for that improved practices, CSA, will improve food security, adaptive capacity, and mitigation objectives. And also it's based on the fundamental assumption that we have some idea about the synergies and trade-offs between these different components. And so what have we been doing so far? We've been trying to make a sense of essentially what is a pile of disparate literature. And so we've been doing a meta-analysis and a systematic review of 65 practices and 15 indicators. And so when I say practices, we're not talking about the aggregate level of agroforestry. We're talking about things that farmers actually implement on the ground. Leguminous and intercropped agroforestry, deep placement of urea, things that farmers would actually need that you can analyze individually and then also aggregate back up. When I talk about indicators, these are indicators of food security, adaptive capacity, or mitigation. For food security, we're looking at 4 main indicator categories ranging from income, productivity, and such. In terms of adaptive capacity, obviously this is the hardest one. We're thinking about things like soil quality. We're thinking about gender differentiated labor. We're thinking about nutrient use efficiency, water use efficiency, and things like that. Mitigation is a little bit more straightforward, carbon sequestration, greenhouse gas intensity, and the like. And so what we've done is essentially we utilize discipline-oriented keyword searches in the Web of Science database, and we came up with 144,000 candidate papers. And with the help of a small team of master's level students, including Helena, who's in the audience here today, we went through all 144,000 papers and tried to see how they matched our inclusion criteria. So here we were interested in whether or not they had information and data on a CSA practice and a non-CSA control, as well as whether or not they took place in a tropical developing country. So from that 144,000, in reading those abstracts, we narrowed it down to about 16,000 papers. And those papers, we then downloaded the full text and further analyzed them to see if they met our inclusion criteria. That left us with 6,000 papers in which we had to actually extract data from that we thought were relevant to answering our main question, which is climate-smart agriculture, panacea, or propaganda, or in other words, what is the evidence base behind climate-smart agriculture? So far, we've extracted data on about 20% of that. And so I'll be talking about that. Based on the numbers that we've already extracted, we presume that in the end, this database, which will be hopefully ready by the Montpellier CSA conference, if not a little bit later on in the year, will have about 120,000 individual data points in it. Okay. And so if we just start to map where the studies have taken place to see where and how and what information is available. These are the studies that we have. This is a random sample from our 1,200 studies that we've already looked at. where they're actually located on the map. And these studies they're talking about at least one indicator relevant for food security, adaptive capacity, or mitigation. You see that it's a pretty good global distribution. But if you look a little closer, you also see that there is some geographic clustering. That you see that in Western Kenya and maybe around Accra in Ghana, there's actually quite a number of studies that are in a relatively small location. And so what does that mean for when we're trying to scale climate smart agriculture? Well, what it means is, or what it suggests at this point, is that we may have a biased data set, that our information base may be inadequate to be able to say that this type of practice will have this type of outcome in a new location. When we then go to studies that have two practices, or that address two components of CSA, like food security and adaptation, in the same study, the size of the data set reduces dramatically. We basically lose 60% of the studies. And so why is that important? That's important because what we know from about 50 years of agricultural research and agricultural for development research is that a lot of time interventions are place-based. So we can't presume that the types of interventions and the types of outcomes that we might see in one location are going to be able to be extrapolated to another location quite easily. And so these synergies and trade-offs may not actually be transmissible. And lastly, if we look at studies where we have all three indicators, probably given this projector, you might not even see any up there. But there's just 7 dots. So we basically reduced it to less than 1% of the studies looked at all three components of CSA in the same study. And this is important simply because it greatly reduces our ability to characterize what is normally thought of within climate smart agriculture, which are these triple wins, these win-win-wins. When we start to look at the data and actually use common meta-analytical techniques, so this is the food security response across multiple indicators for 6 different practices at different aggregated levels. And that sounds a little complicated, but let me go into a little bit more detail. And so, wrong button. So this is an effect size. So an effect size measures the relative effect of the treatment to the control. And so anything to the right of that red line is a positive effect. Anything to the left of that line is going to be a negative effect. If it crosses that line, it's not significantly different than 0, and you may have positive or negative control or negative effects. And so basically what you see here is that there's not only a wide variability for any given practice, for instance in agroforestry, but there are some clear winners. The use of inorganic fertilizer seems to be quite positive. The use of increasing protein in livestock feeds as well. The interesting part is that in most cases, people are talking about climate smart agriculture at a very aggregate level. They're talking about agroforestry as climate smart. Well, as you can see in these top two panels, once you start disaggregating the data from agroforestry to actually leguminous agroforestry, the actual effect changes. And so I would argue that you would need to actually begin to think about it in this more disaggregate level when you're identifying things as climate smart. And lastly, let's look quickly at some synergies and some trade-offs. And so this is just the synergies and trade-offs for the adaptation and food security indicators that are in a 130 random sample of 130 studies. So as you can see, there are only 55 comparisons in that 130 studies, so that's back to the about 60% decline that I mentioned earlier. And everything in the red box in the lower left-hand corner is where you don't want to be. This is lose-lose. So about 6% of the studies showed that there were lose-lose effects between adaptation and food security. In the opposite quarter, in category, there's about 32% of them showed that there were actually synergies. So this is what everybody is saying is possible with climate smart agriculture. But equally important, 60% of the studies that we looked at, and granted it is a small data set at this point, shows that there's equal or more likely chance of actual trade-offs between adaptation and food security than there are synergies. And so while today I've just really focused on a very small amount of our initial data, the emerging trends seem to be somewhat clear, that there's geographic clustering of the studies, which would suggest that we have challenges in actually extrapolating the data. There's a likelihood that we will see trade-offs as much as we would see synergies, as well as that there's large variability amongst and within individual practices. Thanks.
Okay, thank you. So before we go to some questions, we'll have another round of panelists giving their sort of views on what they've just heard, also just making some statements in regard to, let's say, the alliance here. So let's start off with Martin, and then Lami and Austin in that order. And I'll ask you to be fairly brief so that we have as much time as possible for questions and answers where you can sort of elaborate more on any issues you might want to raise. Okay? So, Martin, you want to kick us off, please?
Thank you very much. Okay, yes, it's working. Thank you so much, Moderator Henley. Yes, I'm going to be very brief, and thank you so much to the two presentations. I think they do give us a very good scope in terms of the discussion. Now, and I pick it up from the messages, key messages out of the two presentations. And I would say, is it possible, looking at what we've just heard in terms of what is climate smart agriculture, is it possible then, or is it correct to say that in fact climate smart agriculture is just any good agricultural practices? Anything that is actually good, and underline the word good, is going to give us productivity, food security, is going to give us adaptation, is going to give us mitigation value. And sometimes when you look back into what we have described and what we've known as good agricultural farming, when we say climate smart agriculture, are we saying anything different? What is new in this? And I start by saying that yes, in fact, there is something new, there is something different. One of the first important issues is that in dealing with and talking about climate smart agriculture, we want to go beyond just the issue of securing productivity. So this is more than just productivity issue. There is something that is actually very, very clear about the threats that climate change, or the opportunities that climate change bring on the whole spectrum and space on productivity and on the food systems. So you're looking at everything that we're doing in terms of farming practices, or what you call agriculture, and look at how far is it going to support enhancing ability to deal with the new emerging trends and threats, opportunities that are very specific to the occurrence of climate change, climate variability. And this, again, is about understanding the actual risks, which are actually are very localized, is appreciating the actual opportunities that you attribute to that climate change. The second point I want to make is that when you look at climate smart agriculture in terms of what is different, and in terms of those practices, it is actually that is something that is compelling beyond. We talk about holistic, comprehensive approaches, but in climate smart agriculture, we are seeing a very practical compel to look at agriculture, to look at farming in a very, very integrated, holistic. And I like what the moderator was saying in the beginning, that is more than just climate smart technologies, but that we look at climate smart systems, because it's about practices, it's about policies and institutions, as mentioned, resources, but it's also about managing the trade-offs in terms of different constituencies, but also the trade-offs in time and space. So what are we doing today vis-a-vis what are the needs, requirements of future scenario? And the last and the third point in terms of the practices of climate smart agriculture is actually the value, and the one issue about climate smart agriculture is actually how much it should bring back the value, the benefits into the local circumstances, both in terms of environmental resilience, social resilience, but today, especially when you look at Africa, the issue is how do we support the communities to harness their resources, land and water, in terms of increasing access to economic or expanding economic opportunities, and actually enabling them to move in that spectrum towards a prosperity. Thank you.
Okay, thank you very much, Martin. We now have Fabiola Munoz Dodero, who is the Executive Director of the National Forest and Wildlife Service, SURFOR, here as well. It's a pity she couldn't make it to us a little earlier because she missed the presentations, but I'll give her the chance of listening to the respondents so then she can make something out of that, and we'll have more chances to hear afterwards. Okay, well, thank you very much for coming anyway. It's great to have you. Lami, please.
Good afternoon, ladies and gentlemen. When I was being introduced, they said that I'm working for an organization where we're working in a policy space. I would like to throw that into the discourse of climate smart agriculture. I listened to the presentations, and I also listened to the presentations before this session yesterday. What I'm seeing as a missing link, it's the enabling environment that we all agree that it's part of what will make our efforts for climate smart agriculture to be successful. I just want to share with you the experience that we had with our organization, where we did some scoping studies in 15 countries in Africa, Southern Africa and East Africa, to see how the countries are actually responding in terms of the climate smart agriculture debates and also climate change. What we are seeing is that the countries do recognize that climate change is there. They also respond to the calls for climate change, and most of the discussions are hosted by the ministries of environment. What we have seen with the ministries of agriculture is that out of the 15 countries that we did the scoping studies, there were about 4 or 5 where they have policies that speaks specifically to climate smart agriculture. So as we discuss, I would like us to look at how we can actually accelerate, really for the countries to have the enabling environment that will complement what is happening on the ground. So we find, this disjuncture that, on the ground, there are a lot of experiences, there are a lot of practices that is happening, but there's a gap between what is being practiced and what the policies are saying. So as we discussed, we need to also accelerate on that front. Thank you.
Thank you very much, Lami. That's a very important point. And Alexandra already mentioned it, that we need not only look at the technologies. That's very important. Austin, please, just give us your thoughts.
Oh, thank you very much, moderator. From the introduction, I think I'm the most tail-end panelist here. I am from the extension side of all these practices, so I'll focus my comment on what it takes to scale up climate smart agriculture practices. I like the matrix that Todd presented. I think it's 4-dimensional, but as we go out in the field, the matrix could become 100-dimensional. When we are working with the farming communities, the issues of productivity, yes, they come in, the issues of costs, the issues of resource saving, environmental issues or indicators, and also the institutional indicators that we have discussed in the presentation from FAO. So when we are at that level, we must make sure that all those indicators are satisfied, and that's the main challenge that we face. In climate-smart agriculture, we have observed that those practices, they do respond to as many of those indicators. And my suggestion to the meta study that we are conducting under aircraft is that we should go on beyond the 3 indicators to satisfy what the farming communities need or what they expect from these practices. And finally, I would like to suggest that we have quick policy briefs to our decision-making people, the politicians, that crisply presents what we expect or what we suggest are the winning solutions to the challenge that the farming communities are facing because of the effects of climate change. Thank you.
Thank you, Austin. And that's very important for us to talk about the question of scaling up. I think we should hear more about that. It's one thing to know the benefits in terms of adaptation, mitigation, and food security, but then another question altogether might be how can we reach these millions of farmers that Todd was already mentioning? Fabiola, do you want to say a few words with regard to climate-smart agriculture and potentially your own experience here out of the country? I don't know.
Sí, bueno, buenas tardes con todos y con todas. Me disculpo, además, tuve que reemplazar al ministro en otra sesión, entonces no pude llegar a la mía. Pero una ventaja es que parte de la información que se ha compartido con ustedes hoy día yo ya la había visto en alguna otra presentación con los colegas de ICRAF y con gente de CIFOR y con otros que venimos trabajando en esto. Y yo quisiera comentar básicamente 3 temas en particular sobre tecnologías climáticamente inteligentes para una agricultura que esperamos se pueda volver climáticamente inteligente. La primera es el tema del reconocimiento de los saberes tradicionales, ¿no? Que es uno de los puntos esenciales. Creo que estamos muy alejados del tema de tecnologías que han sido utilizadas en el pasado y tecnologías que están siendo utilizadas hoy día, pero que en realidad no llegan a nivel de ser asumidas, por ejemplo, por aquellos que tomamos decisiones. Entonces, esta articulación entre el conocimiento tradicional que rescate esas tecnologías apropiadas y esas prácticas culturalmente apropiadas son uno de los elementos claves, ¿no? Y esto no solamente lo estoy diciendo como Ministerio de Agricultura y Riego, también esto tendría que estar, por ejemplo, en los sistemas de inversión, ¿no? Con el Ministerio de Economía, tendría que estar en los proyectos sociales con el Ministerio de Desarrollo e Inclusión Social. Es realmente el tema del conocimiento, cómo se incorpora en la política pública. El segundo elemento que creo que, si estamos hablando de la misma matriz que yo he visto en algún momento y que ha sido presentada ahora, hay una serie de buenas prácticas y de posibilidades que se podrían convertir también en política pública, pero que a veces en el Estado no tenemos, una de las cosas que se ha hablado, la conexión con aquellos que están haciendo investigación, ¿no? Hay un link que todavía no hemos podido, un chip que de repente todavía no hemos podido cambiar, que es cómo convertimos los resultados de la investigación en algo que informe mejor la política pública. Y ahí yo creo que tenemos que impulsar un diálogo más intercultural entre esas prácticas para convertir a la política pública que promueve esta agricultura más inteligente en cuestiones prácticas, ¿no? La sabiduría práctica de aquellos que finalmente han investigado, han logrado probar y que ahora deberíamos de adoptar. Y el tercer tema, y ahora sí voy a utilizar una sesión la sesión por la que no pude estar acá, una cosa que se está hablando ahorita con ministros de otros países es la importancia de poder incorporar a otros sectores que influyen en el tema de la agricultura o del manejo forestal, que no son justamente ni el Ministerio de Ambiente ni el Ministerio de Agricultura, ¿no? Entonces, si en verdad nosotros queremos cambiar la agricultura en el país, tendríamos que incorporar a otros actores que también son tomadores de decisión y que definen política pública y que no son los tradicionales, ¿no? Justamente en esta discusión en la que estábamos, uno de los temas que se discutía era, bueno, ¿y qué tiene que ver, por ejemplo, el Ministerio de Justicia, ¿no?, en una discusión como esta? ¿O qué tiene que ver el Ministerio, por ejemplo, de Inclusión Social? Y en realidad tienen mucho que ver, porque para darles simplemente una idea, en el Perú, si un agricultor, o sea, si una comunidad o un pequeño va a un área y tala ilegalmente, pone esa madera en un camión y se la lleva, el primer puesto de control lo va a parar y le va a decomisar la madera y probablemente… perdón. Ok, bueno. Y probablemente lo va a denunciar, ¿no? Y van a decomisar el producto que ha sido talado ilegalmente, que es madera. Pero si un agricultor hace exactamente lo mismo, retira la cobertura forestal de un cuarto como este y pone maíz y vende el maíz, nadie lo va a parar. Al contrario, ¿no?, porque es un producto agrícola, aunque provenga de un área que está deforestada. Entonces, si los ministerios de justicia, por ejemplo, que dictan muchas normas vinculadas a estos temas, no entienden ese cambio en la política, es difícil que podamos conseguir también desde ahí una entrada para sancionar no al que está haciendo tal ilegal solamente, sino al que está haciendo una agricultura que tampoco es la correcta. Y eso tiene que ver con un tema de educación, o sea, hay varios aspectos y factores que entran aquí, ¿no? Entonces, creo que hay un nivel de articulación de política pública que todavía no está siendo suficientemente trabajado para lograr instrumentos que permitan tener esta agricultura climáticamente inteligente.
Okay, thank you so much.
Haberme perdido la presentación, además.
No, I think you added a very important element and gave some more sort of depth to the question of what contributes to enabling environments from the political perspective, and I think that was very useful for our audience here. So we have quite a bit of time for questions, and then so I'd like to take 2 or 3 questions at a time, and then we'll give our panel an opportunity to respond. I have Jonathan here in the back. Yes, sir, number 2, and we'll take one more afterwards. What? Go ahead, Jonathan.
Yeah, my name is Jonathan Cornelius. A question actually for Fabiola.
Can you introduce yourself, please?
I
Not
just did.
the institution.
Okay, sorry, Henry. This is Jonathan Cornelius. I'm regional coordinator for World Agroforestry Centre based here in Lima. Okay, yeah, a question for Fabiola. Fabiola, your interesting remarks about the need to close the gap between research and policy. Yeah? And coincidentally, possibly, in our institutions, the CGIAR, we spend a lot of time thinking about theories of change and how our research can change what happens to its intended, or rather can change what our intended users do, shall we say. In this case, how our research can change policy. What I'd like to ask you as a implementer and former of policy is to what degree the ultimate end users of research also have to come back down the chain of impact themselves and somewhere meet the scientists as they try increasingly to work forwards in the chain of impact. Yeah? Hope I'm being clear. What I'm trying to say is that as researchers, we are being asked to be increasingly accountable for our research being implemented, for example, in changing policies. So what is the role of policymakers in also coming back maybe towards researchers and for the two of us together to construct that impact that we all want? Thank you.
Okay, please. Yes, sir? And then the lady behind him as well.
Thank you. I'm Doug Boucher from the Union of Concerned Scientists. My question is for Todd. The graph you showed had what to me was a striking and even paradoxical result, which is that a very large and quite impressive meta-analysis from the World Agroforestry Center showed that there was no significant effect of agroforestry. But you were only talking about the effects on food security. What were the significant variables that affected mitigation?
Okay.
Karina Pinasco, de Asociación Amazónicos por la Amazonía. Gracias por sus intervenciones. Coincido con Fabiola, aunque dijiste 5, Fabiola, y solamente mencionaste 3 de los puntos. Pero voy a hacer un comentario que hice en la sala anterior respecto al tema de climáticamente inteligente, agricultura climáticamente inteligente. Por todo lo que estamos viendo, necesitamos que sea un proceso mucho más integral. Tú mismo lo mencionaste, la articulación de los sectores, el tema de políticas públicas, conocimientos tradicionales. Y ahí venía la pregunta, ¿nos vamos a conformar con que sean agricultura climáticamente inteligente? ¿Por qué mejor no avanzamos hacia economías climáticamente inteligentes, y eso va para todos, o modelos de desarrollo que sean climáticamente inteligentes? ¿Y cómo haríamos todo ese proceso? ¿Cómo empujaríamos todo ese proceso? Porque al fin y al cabo, por ahí creo que podría estar la salida a todo lo que estamos viviendo ahora.
Okay, let's give the panel the opportunities to respond. And yes, let's start with Fabiola, and then I'll pass it on to Todd. And anybody else who wants to say something to any of the other questions, please feel free. Okay, Fabiola.
Ok, sobre la primera pregunta de Jonathan. Si no entendí mal, la pregunta es cómo lograr que tengamos desde el lado de los políticos y los que tomamos decisiones en las instituciones este acercamiento con los investigadores. Okay. Yo creo que en ambos lados, en el lado de la investigación y en el lado de aquellos que toman decisiones, deberíamos tener un poco más de humildad. Yo estuve hace 2 días, 3 días tal vez, en un evento en el Pentagonito, ¿no? En una mesa, y entonces les dije lo mismo que les voy a decir ahora, que yo sí creo que es importantísimo que la investigación nos ayude a tomar decisiones y que todas las decisiones que nosotros tomemos, ojalá en el Servicio Nacional Forestal y de Fauna Silvestre de Perú las tomemos con un sustento técnico, ¿no? Y que una cosa que me preocupaba es que nosotros hemos lanzado hace poco un concurso de posiciones y que de todas las posiciones hemos reclutado como el 30% de esas posiciones y solamente hemos podido tener una investigadora, ¿no? Y entonces los investigadores no quieren entrar al Estado, ¿no? Y ese es un problema. Y claro, una de las respuestas que me dieron en esa sala fue que fácil, el tema para solucionar este problema es que los políticos prácticamente dejen de existir y que solo los científicos sean tomadores de decisión, ¿no? Y claro, cuando uno escucha ese tipo de cosas, igual que yo he tenido esa misma discusión, yo no sé si ustedes lo saben, pero yo soy abogada y ustedes podrán decir qué hace un abogado de director del servicio forestal de un país, porque nosotros en el Perú en este momento estamos en un proceso de reforma y mi especialidad es el tema de política pública. Y entonces una de las reformas que tenemos que lograr hacer es cómo se vincula justamente, generar la institucionalidad para vincular la investigación de una manera sencilla con el Estado, la política pública. Y entonces la primera cosa que creo que todos tendríamos que hacer es aprender a respetar el rol complementario de los otros, ¿no? Y no mirarnos por debajo del hombro, ni los políticos, ni los investigadores, ni los economistas, ni los abogados. Ojalá tuviéramos, por ejemplo, más economistas, más financistas metidos en estos temas. Y creo que todos nos necesitamos. Y eso me lleva a combinar la intervención de Karina y la de Jonathan en este sentido. La respuesta que requerimos hoy es una respuesta urgente, porque no tenemos mucho tiempo, para tomar decisiones acertadas. Y las decisiones van a estar más acertadas mientras más investigación tengamos como soporte, mientras más sustento científico tengamos. Y entonces ahí la pregunta es si solo nos quedamos en la agricultura, y yo creo que no. O sea, justamente el tema aquí es cómo entramos, con el ejemplo que les daba desde el Ministerio de Justicia, pero también cómo entramos desde educación, salud, energía y minas, cómo entramos desde todos los sectores, y creo que ese es en realidad el potencial más importante de estos 2 días de trabajo, que es esa mirada de paisaje, pero no solamente en el paisaje geográfico o físico, sino en este paisaje que tenemos aquí. Si yo les preguntara, por ejemplo, ¿cuántos economistas hay aquí? ¿Cuántos economistas hay aquí? 2, ¿no es cierto? ¿Cuántos ingenieros agrónomos? Vaya, un poquito mejor, 5. ¿Cuántos sociólogos? 2, 3. ¿Cuántos abogados? Y ustedes saben cuántos abogados definen la política pública en nuestros países, pero ¿a cuántos nos invitan? Si cada uno de ustedes, desde sus profesiones, ¿cuántos biólogos hay? Ajá, ¿no es cierto? ¿Y cuántos investigadores hay aquí? Ajá, ¿no es cierto? Miren ustedes, si cada uno de ustedes se propone adoptar un abogado, ¿se imaginan la revolución que podríamos hacer? Pero eso es parte de entender que el mundo ha cambiado y que nos necesitamos entre todos. Hoy día mirar la agricultura fuera del manejo forestal y fuera de la economía verde y es un error. Nos necesitamos. Y podemos discrepar y estoy segura que vamos a tener diferencias, pero la puerta está abierta para sentarnos en la mesa. Y esa creo que es la gran ventaja de un espacio como la COP y de este foro de paisajes. Gracias.
Okay, thanks for this passionate statement, Fabiola. And I think you're totally right about everything. See. Todd, why don't you just respond to Doug's question? I think it's an important question, Doug.
Follow up, great. Appreciate that. I fail to see the paradox, mostly because I'm a scientist and I report what the data say. And so this is the analysis that we've done so far in the limited data set. What you see and what you saw in that graph is largely driven by the variability in agroforestry systems that are included there. There's border planting, there's intercrop, there's legumes, there's timber species, and all of that, which is why you see such a wide range in the effect. And so I would presume that before the end of the analysis, when we've included more data, that we would see a different effect. How large that effect, positive or negative, it's hard for me to predict right now based on my reading of the 1,200 papers. So. Oh, the mitigation effects, we haven't looked at those data yet.
Okay. Martin, do you want to say something about the question that Jonathan raised in the context of science and policy? I think you might be able to add a few words from your perspective, maybe put it into the context of the Climate Smart Agriculture Alliance.
Yes, thank you. Indeed, that is an interesting issue, and it does come up all the time. In fact, in the Africa Alliance, one of the work streams we have identified where we're saying we need to make a difference is on the policy. We have one on the policy stream, and we have one which we're calling technical support. And this is the appreciation of the fact that, and I think in Africa you can say the politicians are coming quite a long way in respecting data, respecting evidence, and beginning to talk about facts and figures. And the problem is that these facts and figures, data, is not existing in the form, in the manner that they can actually use it at the moment. And that is the problem we have. So the issue in terms of research is actually how we can move and actually move very rapidly, not just in terms of technology development, but also support the politicians to answer the questions they need to answer in terms of real, with the evidence, with the objectivity that is desired. And one of the things we are looking at actually as a matter of approach is that when you talk about climate smart agriculture and looking at science, it's a very open space. There's a lot we need to know. But it's also clear that the climate smart agriculture we're talking about, in fact, as implied from the various discussions, is not the same as manufacturing a car in the laboratory and then take it out on the road to be used. The climate smart agriculture is going to be developed in situ. It's going to emerge within the road that you are using it. So it's how we move actually in terms of research approaches, in terms of research tools, in terms of the accountability of what research delivers to actually bring them into the field, working with the farmers, working with politicians, working with communities, and actually it's also because it's not just a technical issue, it's actually political economy, and those things will be critical in making a climate smart agriculture emerge the way we want to see it. We've mentioned actually working with the CCAFs, we're working with FARA, and we're saying also that we need, in fact, just as much political economy research as we're doing on the hardware, on the actual agronomic and technological practices. Moderator, if you allow me just one more point. I wanted also to say that when you look at the discussions on climate smart agriculture everywhere, even in these 2 days, of course it's being emphasized in terms of the comprehensiveness, the integrated nature of it, the holistic aspects. But it's also linking to research to understand that I think we have to be careful that we don't end up with a very perfect creation that is unimplementable. And actually the excellency of the description of climate smart agriculture is not going to come out of a laboratory. It's going to come out of real practices in the field. And I want to end by saying, in fact, in that sense, that's why we need to listen more from what the farmers are doing, what communities are doing, and actually understand that if it's not broken, don't fix it.
Brilliant. Okay, I had you, sir, then I saw you first, and I don't know if you were there, so I have you three. Okay, please. Introduce yourself, please. Can we get a microphone?
Here. I was here first.
No, I saw this gentleman first. He was already raising his hand. I'm sorry.
Thank you. Doug Brown with World Vision International. My question specifically to Todd, but I think Alexandra might be able to help with it as well. Your data surprised me a little bit in a way it was, but I think it's partly because it's a meta-analysis, and of course you're looking at studies that were designed to measure food or productivity impacts or resilience impacts, but they may not have measured the other ones, and so they're dropped out when you sort of start comparing to. So there's a limitation there, I guess, but I was looking at the grid, the quadra here where you have the win-wins, the lose-lose, and then the mixed ones, and I'm just trying to wonder, I know when in the FAO source book, we know that there's a lot of practices listed there, and they're not all equally climate smart. Some score better on 2 or 3 dimensions than others do. So I'm wondering if you can characterize what's in the upper right quadrant versus what's in the upper left versus the lower right, and what practices are dropping down to those things versus the ones which are clear win-wins.
Okay. And yes, sir, please. Now you'll have to go over again. I'm sorry.
Can I take about 2 minutes to share how we have achieved climate smart agriculture and benefited in India?
Yes.
Okay.
So if you would try to be very concise.
Yeah,
and put,
I
and
would
also
try to be, I take 2 minutes.
And try to frame a question as well. if possible.
Later on. But first I would like to congratulate Todd for bringing out a very precise analysis of what is happening and what benefits have accrued. And if this taken further, then the world community will benefit. Now, climate smart agriculture, we started in Gujarat, India, about 10 years back, and we called it as a new extension approach. It is prior to agriculture season. It takes place in all villages together, 18,000 villages. Team is led by agriculture, extension administration, agriculture scientist, input dealer, and market people. And they go and meet the farmers at their doorstep, provide them information what crops they should grow in next season based on prevailing situation. 3 inputs are provided to farmer. One is soil health analysis, which I mentioned in the last session, that what crops their soil will sustain based on the weather parameters. Second is what is market demand for the crops, which crops they should select based on the market, and where the quality inputs are available. This is backed by water conservation measure at village level, which is funded by the government with community participation, so not a drop of water goes out. 70% of our area is rain-fed. Focus is on women farmers and rural youth. And rural youth are trained to identify what are micro enterprises possibilities based on local agriculture produce. So it's a comprehensive approach, takes place every year prior to agriculture season. And what has happened in Gujarat, India, and which is now going on all over the country, the soil health card approach and everything, is that we had a -2% to +2% growth rate. We have now reached 9% growth rate in 10 years at constant price. So almost income of farmers have doubled and on par with non-farm sector. So if we follow this approach in a comprehensive manner, there will be less social turmoils which are happening in many parts of the world, and people are trying to grab justice by brutality. Thank you.
Okay. Thank you very much for this comment, and I'm going to ask your intervention first, please.
Okay, my name is Talendasim Tunzi, and I'm with Fanapan. My question is basically on coordination, taking into account that CSA is at a global level, and also we have got the CSA Alliance at the African level. How are the coordination modalities? Do we have an implementation framework or a monitoring and evaluation framework at a global level that resonates with other regions? And are we following a bottom-up approach in terms of coming up with those kinds of frameworks? And the other question is on the CSA technologies. Do we have context-specific CSA toolkit or technologies that we have to really say this is what we call climate smart agriculture, or it's just the 3 indicators that were showed here that indicate on food security, adaptation, and mitigation? Do we have practical, context-specific toolkits that are talking to different ecotypes in the different regions that we are operating in? Thank you.
Thank you very much for this excellent question. So what I would suggest is that Alexandre and Austin, you could try to respond to the Indian gentleman's point, which I think was very context specific, and I think it makes sense to sort of look at the question from a larger perspective. Is it transferable? Can it be done elsewhere? You know, what are the constraints? And because we talk about systems that are context specific, we need to make sure that they actually fit somewhere else. And then, Todd, if you answer Doug's question, of course, and Rami, I don't know if you want to step in also looking at the questions of coordination, potentially. So, Alexandre.
So the first thing is that, which is why I was saying that we're a bit uneasy with this idea of climate smart technologies and climate smart practices, because it is very context dependent. It's ecosystem dependent, but it's also socially dependent. It depends how the communities are organized. It depends how the policies are supporting. It depends on the economics. And so from our perspective, what we need is having more examples of what has worked or what has not worked, with the various impacts and why it has worked or why it has not worked. What is the context which is around? The ultimate objective would be, I don't know if it would be toolkits, but information tools, knowledge platforms, call it how you want it, where practitioners or actors at whatever level, from governments, policymakers, of development practitioners or farmers, could go and have a look at situations which are as comparable as possible to theirs, or one aspect of the situation is comparable to theirs. So that's the objective, and you're right, it needs a lot of coordination. This event is part of it. The huge work done by Todd is an essential element of that, but there is still a lot to be done. But probably the biggest, from my perspective, the biggest mistake to avoid would be to say, oh, that's a solution. Just implement it top down. This wouldn't work. And not only it wouldn't work, but there is a risk of having wrong impacts in another dimensions. I think one of the important things with climate smart agriculture is that we say in the beginning, you have to look at the three things. You do not necessarily need to address them at the same level. The win-win-win thing is a myth, maybe. But you need to look at the three, and you need to know what damage you're doing in another dimension when you want to do something. And that's probably true for all natural resources issues or even development issues. But yeah, maybe and this probably is part of why the Quarter and what so many trade off, because it's not the same everywhere, but probably you'll be more able to answer it that way.
Okay, thank you very much. I'll start from where Alexander has stopped on the toolkits, yes or no. In some areas, we are trying to draft some toolkits or some messages on climate smart agriculture practices. I'll give an example of the EPIC projects in Vietnam, Zambia, and Malawi, where we have looked at we have started looking at the trade-offs in terms of mitigation, all those triple wins, mitigation, food security, and adaptation. And we have isolated some examples or some practices that are fitting well within those win-win-win. We are also doing some institutional mapping on how to move on or outscale these practices. And we are also doing some policy harmonization. I think my colleague Shema indicated that in some areas or some regions, we have a gap between the environmental sector and the agriculture sector from policy and institutional setup on how to handle the issue of agricultural practices that are climate smart. From my colleague from India, that's a very good example that he has indicated, and I'm happy that a few months ago I was in Maharashtra, and I observed the same best practices on what they were calling the advisory services. Within Maharashtra, they were able to combine the water budgets, the hydromet services, the weather forecast, the available water for irrigation, the onset of the rains, and the prevailing economic and social conditions, the markets, the agroecological conditions, the soil fertility, to precisely advise the farming community on how they can modify or improve their farming system. And I really agree with him that it has really improved the productivity of the farmers, but also the resilience of the farming system.
Welcome to Precision Agriculture in the Southeast. This program is funded by a grant from the Alabama soybean producers and the Alabama wheat and feed grain producers. With me today is Dr. John Fulton. He's our Precision Ag guy. John, you've done great things with our Precision Ag program. Today we want to talk about variable rate technology. Variable rate. I understand that. Technology a little bit, but different amounts for different areas. And small areas, tell us about variable rate technology for agriculture.
Well, this is one of the areas that our Alabama farmers are really starting to capture some benefits. We saw a lot of interest kind of in the 90s, early 2000s, and it kind of plateaued. But more recently, we're seeing a lot more adoption of variable rate for various inputs. So going back to considering that input stewardship, which is just a must today in these businesses. The farm operation has to use inputs efficiently, and this is the real technology that enables that to occur, whether it's seed, fertilizer, lime, and some of these other inputs. So anyways, talking about variable rate today, Mark, and just simply put, it's trying to base your application of inputs on some kind of field or crop variability that we either measure or understand out there, and then only applying what's needed back to that crop or soil. And the big thing, and we promote in all this, at the end of the day, when we start to break fields into either zones or grids, we know that we're going to be able to more accurately deliver inputs for the crops that we grow on our farm. So variable rate application, or VRA, is a term that a lot of people use, or it's really the technology, or variable rate technology is the second level. We've got to have the technology in order to implement the VRA program that we choose. Here's just some quick things. A lot of people, when they hear variable rate, they think very quickly to fertilizers, basically granular fertilizers for P and K and nitrogen in a sense. But lime has been one area that our farmers have really capitalized and seen a profitable benefit to doing variable rate application. So that's one. More recently, a lot of talk, as you know, around variable rate seeding with seed costs, but also planters today coming from the dealer with hydraulic drives as shown in the bottom right. All of a sudden the question is how really can I take advantage of that drive considering my seed costs, and can I do a better job of adjusting populations based on some kind of variability that we measure or know out there in the field. So that's kind of two quick examples that a lot of farmers of fertilizer, lime, and seeding have been really the pioneers in Alabama for variable rate application. The concept itself, implies that you're going to vary some type of input. Typically, we're going to think about that as a rate or a population for planters. We're really wanting to understand the spatial variability out there, and then ultimately the two things, Mark, that we got to drive down to, and these are not easy questions to answer, is what's that knowledge? Where am I going to put what and how much? And that's probably the huge question that most guys are going to really have to face and work through. And that's something a lot of times we have to learn over several years in terms of really kind of fine-tuning our variable rate application program at the farm level. The method is really comes down to the technology. That's what we're going to talk a little bit about today, and just give a little insight about how you do it, but really what technology do I need in place to implement this and enable me to build that variable rate application program.
John, this would be one advantage of working the same fields year after year, because if you go to a new field, you won't know. It'll take you a while to build the data points to know how to vary the rates.
And understanding the history of that field, as we know over the last 30 or 40 years, we've gone from some fields that were somewhat smaller, tore down those fences, and all of a sudden knowing that history just in itself brings in that idea of doing some variable rate based on management history. But the biggest thing that we talk about from a variable rate, that knowledge, there's no replacement for that farmer knowledge. And that's the number one data layer, in our opinion, that really needs to be implemented or discussed about what do you know about that field, or what makes sense to do in that field. Capturing that data is very critical and to be successful in these programs. With that, again, going back to what we've shown prior, that again, we're looking at a field that's irrigated, but you can see some areas where there might be some differences in water holding capacity in this particular field. But from a variable rate perspective, I mean, we can go across the board, Mark, and talk about any input today. One of the more recent hot topics is variable rate irrigation.
Yeah.
Really, how can we capitalize with some of the potential constraints on water usage and some of the legal aspects ongoing between states? We want to be smart in how we use our water, but in a sense, fertilizer really starts to make sense. In some cases, nitrogen in particular on some crops like corn can be profitable. Lime, no doubt about it, we got to have our pH in the right range, and going out and a lot of times we'll find hot spots or cold spots, and just getting the pH right.
Look at that picture in your slide, John. That cries out for variable rate nitrogen right there.
Yeah.
Some of it's saying I've got plenty, and some of it's saying give me some more.
Absolutely, and that is a cornfield, so that's a very good observation. That it seems to make that might be what makes most sense for me on that field. So, anyways, kind of moving forward, and this again going back, and these are just examples. We like to see a lot of data layers, or a few data layers that, especially those yield maps. You can see where we're on the left, blue's high and red's low, and so you can definitely see there's some differences in yield in that particular field. If we can build a history of that over time, we can see a fertility map there where we got some really high P and K. Actually, if I'd shown you both. Fertility levels, so why don't we don't want to be applying that out there. To implement that, I can come up with a prescription rate. In this case, just as an example, this is just a pH. Again, you can see there was some areas that really need to be addressed in pH, and helping some areas get back up to that production level that we expect. So there's a quick payback for that. So just some ideas here. We got to have some data in hand. Typically, we like to see yield maps. We probably go out and implement some soil sampling strategies, grid or zone, taking that and turning that around into a prescription map. And that's where it gets a little sticky, is who's going to make that map for you, that prescription map? Is that something you're going to do in-house as a farmer? Or are you going to reach out and work with someone, whether that's a input supplier or some kind of data, third-party data manager that would help me generate those prescription maps. So anyways, talking about the actual technology, this is a very simple representation. Typically, we're going to have a display there in the cab. That's going to be our interface. Also, that's where we're going to stick those prescription maps and record data in the cab. We're going to, of course, have to have a DGPS receiver. We talked about GPS versus DGPS, but we want something that has the best, as good as accuracy as we can. We can get away from with WAS a lot of times when we talk about fertilizer. The metering device, and that's going to vary by the implement or applicator itself. And then we're going to have either a hydraulic motor drive or electric drives are becoming very popular. That's going to vary the rate. In this case, we're looking at a traditional spinner spreader fertilizer lime applicator. It's an apron chain that's basically the speed of that chain is going to drive what the actual application rate will be. So we load our map in the top left, we got our GPS, we know where we're at any point in that field, and we're going to apply what that map says in this case, and the hydraulic motor is going to do all the control aspects or the speed of that chain. Just a simplified kind of flow chart here. Again, we have to have some kind of actuator, we have to have a computer and some kind of controller or variable rate controller that sits in there saying, hey, we need to apply 57 pounds per acre, for example. That actuator will adjust the product to that rate, and on the backside we get a controlled application of 57 pounds per acre. We have some kind of feedback loop that tells us what the actual rate is or speed of that chain. When it's calibrated, it says, yes, I'm putting out 57. That's what the computer's telling me. And so we're assuring that we're getting very accurately that application rate put out. So that's just kind of the overview of how this works. The question is what's out there for actuators, and what kind of computers or controllers, and we'll try and go through some of that here. From an approach perspective, Mark, you can do manual adjustments. You can take some of these displays and very simply just either with a knob or most of these touch screens, I can just move the rate up and down myself. That's an ability for me to just look at, do I get a response on my farm? And so I don't have to go to all this, buying a receiver and buying the ability or trying to figure out the ability to generate maps, the prescription maps. Maybe I just do some simple manual adjustments out there in the field and just, do I get a response for my operation? That's just a very good kind of entry level, simple.
I mean, you would know where the low spots were from history and do it
Absolutely.
that way.
And I've heard, we've had some farmers that, especially on the planting side, just go in the field and we either make strips or we adjust based on that, and we just use yield monitors just to see if we get some kind of response. If we get some kind of response, we're probably going to look into this even deeper and probably make a full investment in a suite of technology for our operation. And so that moves us either into the map-based or sensor-based. We're not going to talk much about the sensor-based today, but the map-based is the most popular here in Alabama. But essentially you're generating that prescription map as we showed prior. We take that, load it into either the tractor, spreader, whatever that might be, and based on our position in the field, it's going to put that rate out at that location. Sensor-based, which we're really excited in the program. We see a lot of potential in the future. We still have a little bit of growth to do, but it makes sense for nitrogen and some of the grain crops, small grains in particular. But essentially what we're doing is sensing that crop real time and adjusting the application of nitrogen in this example based on what that crop is telling us. Trimble's Green Seeker would be a good example. Topcom's Crop Spec, those are commercially available sensor systems out there. There's others that are definitely available. Those two are probably the most prevalent here in the Southeast for our farmers or input suppliers to use and provide that service back to the farmers. Sensors, again, we think they're the real future because if we can adjust rates in season. And so a lot of times when you're doing a map base, you build those maps prior to the season or early in the growing season and go out and apply. Crop sensors will give us a look real time at that crop based on where we're at a growth stage and apply just hopefully what we need.
Well, like we were talking about earlier, a lot you can tell by seeing and automated where they the density of the green. How green is it? Well, that would affect whether you were putting out insecticide or fungicide or nitrogen or a lot of issues that you could tell with a color reading.
Absolutely.
And that's just, wow, who would have thought that just a little bit back? This is cutting edge stuff, it seems to me.
Yeah, and I think we're just kind of see that basically the sensors grow. I mean, we're starting to see some interest in that, and it's exciting that because that really drives down to kind of the essence of what we think about when we consider site-specific management. So going back, we're going to focus, again, a lot of rate controllers. This is just an example of one. I can be going across that field and again just turn the knob and adjust the rate right on the go. Okay, and again, I don't need the GPS. I don't need much.
Yeah.
It's just, hey, can I look and see if there's a response? I can do strips. I could be low, kind of nominal rate, high rate, and do some strips and just look at my yield map. If they stand out, then probably want to look better, a little closer into my variable rate program. Again, here's the prescription map, and the question is, how do you develop this? This is a grid-based map, 1 acre grid-based map. 2.5 acre grids are generally what most people would consider potentially profitable, but you could do zone-based. Ultimately, we believe zone-based is where most people will go to, but coming up with these maps can be very complex because do I own the land? Do I rent the land? What knowledge do I have? Do I got yield data? And what's bringing that soil data and some other things in? I mean, it's just not a cookie cutter or silver bullet approach in all this. So a lot of things go into how we come up with these maps.
And once again, if you have a history, if the same person's been working the land for a long time, he knows where the zones are. And it's easier for him to go in there and test for whatever and go with that than it would be. And I think about John, have you ever worked with those maps that they developed in the 1930s, soil maps? And man, that data is almost 100 years old now, but it shows those zones through fields. And it's been my experience, you go in there and test and do 1 acre test, boy, it conforms to that 100-year-old data.
Yeah, I mean, the soil map data, and that's freely accessible today, is a place to start with, no doubt about it. But most of the guys will find very quickly that they're going to adjust that. So they might go out and kind of use the soil maps, maybe yield maps to kind of get started. But in years 2, 3, and 4, they'll note that I find out as I build that knowledge base, I need to really change those zones even more. So, or the grids, I start combining grids, or hey, this grid, there seems to be something going on based on the yield map. I need to go out there and do some very strategic ground truthing, whether that's soil or crop related, to figure out what's going on.
And once again, like you've said, this is not just fertility. This is insect control. I mean, you get an insect problem, it's not field wide, it's zoned.
Absolutely.
And disease pressure is not yield field wide, it's in a zone.
Absolutely. Absolutely. So we just list out the steps here on kind of the general approach. This isn't absolute, but it kind of gives an overview. How do I develop those grids and zones? They got to make sense for your operation is what we want to emphasize. There isn't one thing. What works for you, Mark, might not work for me. Then you got to figure out what rate that I want to apply in each zone, whatever input that might be. And then you got to, from there, generate this prescription map. You either have to have the software in-house or get someone to help. The big thing, the two key things is make sure your units are correct, pounds per acre, seeds per acre, whatever that might be. It's very important that what's generated in the map matches up with the technology I'm using on the equipment, because if it doesn't, you might get a little surprise. The other thing is make sure that when I export that data file or that prescription map from the farm software, it's exported for my display specific. So if I'm using the John Deere 2630 behind me, most of these softwares would have a suite, say John Deere. You can give the display. So when you take it and bring that thumb drive out to the tractor sprayer or whatever that might be, that it works for that particular piece of equipment. So those are two important things, the units and the fact that that prescription map is built for the very particular display that's in that equipment. You upload that, you need to configure your equipment. That includes configuring where your GPS is relative to the point of application. Most of these displays, like the 2630 behind us, do a very good job. There's a little setup. Hey, I'm planning. Where's my GPS receiver relative to the planner unit? They'll usually give graphical representations in there. You can get your tape measure out. But getting that all set up is very critical that you have success out in the field. You need to calibrate. We'll talk just a little bit about that, but that's important. We're really emphasizing it's not just variable rate that really helps improve my stewardship, but it's being able to really dial in rates very accurately, and that's really what a lot of this technology gives. You know, it's always a surprise that we never realized where we were based on. And then you can go out to the field and implement. Just some examples today, Mark, just giving everyone, we'll start with planners. You know, we think back to the days with the manual drives. You got these basically a transmission that sits at the center of the planner. You got to go out and adjust that transmission based on the crop and what's your desired target rate. You normally will get out the operator's manual and they'll have tables that says, hey, this rate, you need to be in this gear transmission based on the seed plate or meter that you got. Very difficult to correctly set, and it's very difficult to calibrate. You know, I can't back in my shop and calibrate that planner in a lot of cases. We take that transmission out, we put a hydraulic drive. Here's an example of a Trimble Rawson drive. Basically, it was a Rawson drive that Trimble's purchased, but you take all those chains out, you put this hydraulic motor, and you got more of a fine-tuned adjustment. It's just not rate. So that's all we're doing. We're taking that mechanical drive that has a bunch of gears, throwing the hydraulic drive in. You got to have the display. Typically, what we call an electrical control unit will sit between this, just a box that has your wiring harness plugged into, and that electronic control unit communicates between the display and a hydraulic motor to drive what the exact rate that you want to put out. Here's a litter spreader, but this could also be a fertilizer. Essentially, we take and put a hydraulic control valve on. There's several out there on the market. We also have to add a feedback mechanism. Basically, in that lower left picture is a Dickey John encoder that just tells us what the speed of that apron chain is turning. With a little bit of calibration, knowing the density of the product, we can very accurately meter product. So if I want to put 1 ton, 2 tons, or 3 tons, knowing and doing some calibration based on the speed, I know how much exactly I'm putting out. But the important thing is, again, you notice that hydraulic drive. Basically, in a lot of cases, these litter or some of the fertilizer, smaller, will come with a manually set. But again, you manually set it and it doesn't have any flow compensation. So as I put more a heavier material or lighter material or anything like that, it doesn't compensate. I essentially put electric operated valve, in this case what we call a pulse width modulated valve. You see a little solenoid on there, and that basically will control the rate applied automatically no matter what my, based on the feedback of that encoder. So we're just swapping out an older valve, about a several $100 swap out, as long as I got the display and, again, an electrical control unit that can communicate with that pulse width modulated valve. I'm in the business of being able to go out and adjust rates on the go. Here's all the things, and people can study, but the display, the receiver, you see the electrical ECU, that essentially, again, is the connection between the display and the valve itself, and also reading in what that feedback mechanism, in this case a coder, so we know at any point in time very accurately how much we're putting out, and we control that based on the map or just from the screen. Finally, we'll talk a little bit about a nitrogen side dress unit, very popular because nitrogen, especially in corn, starts to make sense that you could see some benefits to that. Here's the John Blue piston pump. You've probably seen this, Mark, a lot of times. It's basically wheel-driven or ground-driven pump. We take that. We really can't do variable rate with that because as we speed up, it puts the same rate out and things. But essentially, I take that wheel-driven device off, and I put a hydraulic motor that drives that pump directly. Add the ECU, and in the cab I got a display, and all of a sudden I can really easily fine-tune my nitrogen rate on that side dress unit. There are some sprayers out there this very same setup could be used on. So again, just kind of giving an idea of some of the components. Today, a lot of times in some of the cases, especially on planters, we're starting to see electric motors essentially, and not hydraulics. So with that, just a few things. Everything, variable rate gives you a lot of capacity to really fine-tune your input management programs, fertility, things like that. But there are some things to consider. We're going to just talk about one in particular, and then talk about rate control in terms of how long it takes. But the first thing is, let's just make sure that we're checking that applicator. This is a variable rate nitrogen side dress unit. You can see that there were some issues just based on the picture and the streaking that occurred. But that set up and just checking and getting off and checking that every nozzles, you don't have any plugs, things like that on a row is very important, or this is going to happen to you. So we really encourage people, because of the ability, you can really calibrate these systems. You do it in a stationary position. You get into the display and say, I want to do a calibration. If I say I'm trying to drop 30,000 seeds per acre, it'll drive. You can do a quick weigh and knowing the number of seeds, the weight. You can very quickly get your planter really fine-tuned into that target rate. Same with the nitrogen applicator. And then in the bottom right, we always encourage people to really fine-tune their fertilizer spreaders. We can basically weigh that material coming off the apron chain to make sure that what the computer thinks it's doing is actually, and we can get that down to 2 to 1% or less error, which is really where we want to be, not 5 or 10% that we'll get a lot of times with some of these manual-driven systems. So with that, the last thing I'll say about that is not everything happens instantaneously, but there's a benefit in most of these systems to set what we call a look-ahead time. We just shift to make sure that rate change occurs. So again, a look-ahead time is a value. Typically in most of these will be somewhere on the order of a half second to 3 seconds, depending on the implements. And most of your dealers or equipment companies can really help you know what that value should be. The final thing I'll say is the fact that all this technology gives us the ability to collect data, post, and look at that. Just a quick, we can actually verify what we did out in the field. It's a good record-keeping device. I think as we move forward, Mark, and some of the regulations and things, these will be necessity in order to kind of that verification. Someone does audit you, but it basically can tell you when, where, how much, and ultimately in some cases you could build some research within that field that you could come back and use the yield maps to see what kind of response you got. So a lot of power in this type of data if used properly. We're starting to see a lot more of this used as a means to do some on-farm testing, but you got to know what you put out there in order to make sure that what you're measuring is what you think you're measuring. So with that, we talked a lot about components of variable rate applications, specifically to the technology. We didn't get into the zones and grids. We'll do that in another lesson, but the idea here is the technology can really advance, and the idea of really fine-tuning and getting your target rates right, whether that's population on the planter or pounds per acre that you're putting out with your spreaders, we can really do that much more accurately with this technology, and that's probably the biggest benefit it provides, the ability to calibrate and ensure you're within 1 or 2% of what your target is out there. So with that, hopefully we've kind of covered vertebrate technology in a broad sense.
John, you've done planter clinics and sprayer clinics, and I didn't put the two and two together till now that your planter and sprayer, it's got to be actually doing what it's saying it's doing. It's got to be putting out the seeds or the ounces, and the ground speed. It's got to be exactly what it's telling you to achieve all these things. And I know that having your planter work right is a big deal, but I didn't realize that on this variable, it's absolutely necessary.
Yeah, and it's, anytime I look at, we'll call it a rate controller, what's put on that screen, you want to make sure you calibrate to ensure that, is proper. You can get in situations very quickly where it says you're putting out this rate, but in reality, because you didn't calibrate or check something, we've seen 10, 15, 20% off, and that's not where we want to be.
Well, and the other thing you just touched on, but legal, not our legal, but producers' legal. If you've got a map, if you've got documentation, this is hard documentation. It's not my word versus your word. It's my maps, my documentation versus your yeah. And that's going to be a good thing. Absolutely.
If I can show that someone comes and says, well, you were out in that field last week and I saw a little bit of drift, or some of the guys applying litter, there's always scrutiny around that from the neighbors. But if I can show when I did it, I did it in the proper way, and it was all within legal bounds, that's a much more powerful tool. Now, how much value that is, well, no one maybe will ever ask you, but if someone does ask you, and ultimately,
and you've got that.
It's,
and it'll keep it from going too far down the road. If you've got documentation and they've got just saying,
that's right.
Well, no lawyer's going to take that case.
That's right.
They don't want that. Thank you, John. Appreciate your help. We'll have more on precision agriculture in the Southeast. Please tune in.
Professor P.C. Keshavan is involved in harnessing science and technology for human welfare, particularly in the realm of sustainable management of natural resources, for rural development and livelihood security of the coastal farming and fishing communities. Professor P.C. Keshavan occupied Homi Bhabha Chair and was Honorary Executive Director as well as Distinguished Fellow of M.S. Swaminathan Research Foundation, Chennai. He was the former Director, Bioscience Group of Bhabha Atomic Research Center, Government of India, Mumbai, and the former Professor and Dean School of Life Sciences, Jawaharlal Nehru University. His current research links harnessing frontier science and technology with traditional knowledge for enhancing food and livelihood security without causing environmental problems. Professor Keshavan obtained his BSc in Agriculture from Delhi University, MSc from Madras University, and PhD from Postgraduate School, Indian Agricultural Research Institute, New Delhi. He is a geneticist and radiobiologist. He is known internationally for his work on elucidation of the pathways of modification of radiobiological effects by caffeine. He has published extensively in research papers in genetics, radiation biology, and sustainable agriculture and rural development. For his research works, Professor Keshavan was awarded with J.C. Bose Medal of Indian Science Congress in 2008 and Jawaharlal Nehru Birth Centenary Award in 2009. With this background, I would request Professor Keshavan to deliver his talk. Professor Keshavan.
Morning. At the outset, I would like to thank Dr. Baldev Raj, who is responsible for me to be here. It's very kind of him. I also thank Chairman Raghunathan and Professor Subha Chandran for making my trip to Bangalore and then beautiful place Nayas possible. What I want to do in the next few minutes is to take a journey right from humankind's transition as food gatherers and hunters, that was about 10,000, 11,000 years ago, to doing what they are doing today, to put the planet Earth at crossroads. In fact, I once said in a lecture that Homo sapiens means wise. The humans are so modest, they call themselves wise. Wonderful. But what has happened is that over the years, they have sort of done so many things because of their own ability to do it, that one should appreciate. But they have done wrong things as well, so that they have degenerated into or de-evolved into what I call as Homo destructus. Now, what I say Homo destructus is something not new. It is based on another Nobel laureate who has said that humans have been so powerful on this planet. You know, humans, if you take as Homo sapiens and our brethren species called Homo neanderthals, who for some unknown reason suddenly disappeared from the face of the earth about 40,000 years ago. Since then, it is we, the Homo sapiens, who have marched and conquered the planet. All other animals, for example, take the primates from which we evolved, are known for their ability to live in harmony with planet Earth. But humans have made a deviation from that. Their policy had been, in practice as well, had been to conquer nature. This is where we have got into problem. This is exactly the reason why Paul Curzon, a very Nobel laureate, you have known for his contributions to earth physics, astrophysics, and so on, he coined a term called Holocene. If you take this planet Earth, and we have the data, isotope data of oxygen-18, nitrogen, and also carbon data. People have studied, geophysicists of outstanding capability have studied what has been happening to this planet for over 800,000 years in Antarctica region, dome and they call it. These isotope studies have revealed that Earth has been going through a cycle of 100,000 years of glacial period, that is everything cooling, forming ice. And then this 100,000 years of glacial period is intervened by 10,000 years of warming period, or what you call the interglacial warming period. Now, the last of the interglacial period occurred about 10,000 to about 11,000 years ago. That is the time when humans, until then, who were in their birthday suits and were no different from animals in hunting their food and gathering food, became transformed into farmers. They started domestication of animals, and also that is which they call as the farm animals today, and also cultivation of the grain crops and so on. Now, for the next several hundred centuries, several millennia, there was not a great conflict between agriculture and environment, although there was some, because if I must cultivate, if our 10,000-year-old ancestors had to cultivate barley or wheat or rice or whatever it is. No, rice came to be cultivated much later. Wheat and barley were first, and rice cultivation is only about 5,000 years. So about 10,000 years ago, when they started cultivating wheat and so on, they had to cut down the forest trees to make space for farmland. So that was the first conflict between agriculture and environment, because when forest trees were felled and the biodiversity there was destroyed, many species also became extinct, which were dependent on it. But then that was not worse. The real things to happen came somewhere in the middle of the 18th century, 19th century. One used to spawn Liebig in Gießen. I've had the privilege of having been a professor there in Gießen University for a different purpose, as in radiation physics. That person demonstrated, look, nitrogen-containing compounds stimulate plant growth and also increase productivity. Now the question is, how do you get these nitrogen-containing compounds? For many years, that was not possible. They only used to choose normal nitrate available and apply. Then came Haber and Fritz Haber and Karl Bosch, Swiss Germans. And they developed a process called Haber-Bosch process by which atmospheric nitrogen and hydrogen could be combined under high pressures and high temperatures to make ammonium nitrate. That was a gift to humankind. Because when you apply the ammonium nitrate, the soils are able to provide fertility, the nutrients to the crop plants. That is the inorganic nitrogen fertilizer that we use today. These are expensive, and the government has to subsidize a lot of things to the farmers to help them to buy them. The point here is the plants cannot utilize the atmospheric nitrogen. There is about 73% nitrogen, but this is of no avail to them because plants cannot utilize them. However, there are, in nature and evolution, some plants have developed what they call the root nodules and stem nodules and even leaf nodules. These nodules contain bacteria, a very specialized form of bacteria that can fix atmospheric nitrogen as nitrates in the nodules. And when you plow them in, for example, the African tree, Phaidarbia albida, is a tree that has all the leaves filled with nodules, and it is fixing the atmospheric nitrogen very efficaciously. And the farmers used to, the leaves fall and provide nitrogen fertility to the soil. It is so simple as that. Then in other crops, leguminous crops, all the pulses that we have been endowed with the capacity to develop nodules and fix nitrogen themselves. But the main crops, like cereal crops like wheat, rice, and so on, do not have it. Therefore, if you must have a good cultivation of, a good yield of paddy, you have to apply something like 100 kilograms of nitrogen per hectare. And where do you get that from? That is mostly in the form of nitrates. Now, this nitrate was a fantastic thing. It was, if I may use the term, was a pivot. It elevated the humankind. Now more rice, more wheat, and so on. And that also provided an opportunity for humans to multiply. What Malthus said, these humans, when Malthus wrote this essay in 1798, the global population was only 950 million. And he thought it was a huge one. Whereas today in India alone has 1,250 million people. How has it been possible to belie, to defeat Malthusian scourge? It is because of technology. To that extent, we should appreciate technology. But what technology has done, if you look at the same nitrate problem, it is now known, another potential Nobel laureate in Nature published a paper a few years ago saying the Earth's boundary with regard to nitrogen cycle has been exceeded. That is, more nitrogen has been converted to nitrates in the soil because nature, what it happens in nature is, for the nitrogen-fixing bacteria, there is a counterbalance of denitrifying bacteria. The denitrifying bacteria will reconvert the nitrates into nitrogen and send it to the atmosphere. Now, there is no equivalent opposite of Haber-Bosch process that can only fix nitrogen into nitrates, but not reconvert nitrates into nitrogen. So you are having an imbalance. What is the effect of this? Nobody knows. But one thing is certain. You have nitrous oxide as one of the greenhouse gases. You have it, which is a long-lived one. And you have pollution of the nitrates affecting many river systems, aquifers, and so on. All these are happening. And no way that you can deal with them. There is no technological way to deal with them. So the Haber-Bosch process, which was once a pivot, which elevated, today has become a hatchet. You see that? So there is a very smooth transition from what is a pivot that lifts you and to the one that cuts you. You see? This is not the only thing. Many other technologies. Now I come to Green Revolution. The Green Revolution is a fantastic thing that happened to India. What did it do? Until 1965, I was a student in Delhi. I was not only a student, I was also a student leader. Not like this, the present students of Jawaharlal Nehru University, but I was a Secretary General of the Students' Union, and many times, as many as 3 to 4 days a week, neither would we have chapatis for dinner nor rice. That would come only if PL 480, the American deal, would land a ship either in Madras Airport or Calcutta Airport. Then for us in Delhi, the food grains have to come by goods train. and that will be finished very soon. That was a pitiable sight. That was a time that you must also read the book, Paddock Brothers, economists. They wrote a book. They used the army principle of triage. That is, if you take, for example, countries in those days, East Pakistan, now which is Bangladesh, Pakistan, and other countries, the population is small. If you give food grains, they will survive. But what about India? These people are multiplying like maggots. So they should be written off. Don't give any food grains. So not only was the hunger, but the humiliating remarks contained in that book, famine 1975, America's decision who would survive, that book. And Par Ehrlich's book also was very humiliating. So it is in that background that Professor Swaminathan, along with Borlaug, brought about the Green Revolution in India. Green Revolution, I will show some photographs I have circulated. I think Professor Chandran has already circulated to you. It's a short plant. The idea of a short plant is it can withstand large amounts of food grains on the top of the head, without lodging. So if you want to apply 100 kilograms of nitrogen to enhance the grain yield, then the plant should be short. So the Green Revolution involved the Mendelian principle of breeding to achieve plants which are normally, because originally, when I was a student in Delhi, the Punjab wheat used to be very tasty, but had very long plants and very short panicles, so yield was not that good. So this one's called Sonora wheats and so on. This is God's gift. I don't want to go into it. It happened in this short mutant form of plant occurred in a Japanese wheat field, and at the time Japan was under the American rule, and General MacArthur was the general in command, and when Dr. Solomon saw that plant and didn't have to take any permission of the Japanese government, anyway it was occupied by Americans, and took the seeds to Pullman, Washington, and there Fogel is a plant breeder. He multiplied and produced wheat plant that yielded 10 times more than the conventional dust wheat in America. Now it is this wheat that Professor Swaminathan got, and he said that it is because of the cooperation of Bharat Ratna C. Subramaniam, and also the ICS person. Those days administrators were also very different, Sivaraman. So these three people combined together brought about the Green Revolution. But what is important is that this yield, the Punjab farmers were also something unique. You cannot match them in the world. So dedicated, so enthusiastic. And it is their enthusiasm that enabled the Green Revolution to walk in. And overnight, what happened? India's image within 11 months changed from a begging bowl to bread basket. That was a technology, Green Revolution technology. But even before, at the time the Prime Minister was Madam Gandhi, Indira Gandhi, she decided to celebrate it with commemoration of a new stamp, Wheat Revolution stamp in 1968, June. But before that, Professor Swaminathan wrote, as the president of the agricultural session of the 55th Indian Science Congress that was held in Varanasi, he said, "This is exploitative agriculture. This should not be practiced in long term. This is only to provide a breathing space. For God's sake, let us not continue with it. It will harm the soil, it will deplete your groundwater, and the application of enormous quantities of nitrogen fertilizers and so on will kill the soil health, because soil is not an inanimate structure. What supports plant is not an anchorage that a concrete wall can give. It is the numerous microorganisms which are fixing the nitrogen or solubilizing into potash, or earthworms pulverizing the soil and adding to organic content of the soil and so on. So all these put together is what we call exploitative, that is the term that Swaminathan called. But there was another person by name William Gadd. He was head of the International Agency, U.S. International Agency for U.S. Agency for International Development. And he wanted American footprint on that. And therefore he called it Green Revolution. It also went against the Red Revolution of the Soviet Union in those days, Cold War days. Whatever the Russians, Soviet Union people did, Americans would like to do the opposite. That is how the term Green Revolution was coined. Now, this Green Revolution over the years has shown what Professor Swaminathan said was true. That is, the fertile soils of Punjab. I went there about 2-3 weeks ago when I had to give a lecture in Amritsar. And I saw the plight of the farmers. Two things have happened, what is predicted in 1968. One is the soils have become denuded of the fertility. The soil water, groundwater has been contaminated, And people used, there was also a perverse subsidy. The electricity is free. Every chief minister assured the Punjabi farmers, and the groundwater was lifted up. And when it was lifted up, and the water was flooding the soil, and when water evaporated, what it left behind was salt. The soils became salinized. So wheat is not a crop that can withstand high levels of salinity. So that also yield diminished. So what was a pivot in 1960s, which transformed India's image from a begging bowl to bread basket, it today diminished. Punjab is going to face food insecurity. That is the technology. Then on the health side, nowhere else in India you have such high frequencies of cancer. Cancer incidence is very high in Punjab. That is because the people have had to use a lot of chemical pesticides. And this is the thing. So this is what I want you to say. What is the kind? Then the next thing, people are today talking about the genetically modified food. The term is a very mischievous one. Genetic modification should be restricted only to Mendelian breeding, where you make sexual hybridization between two varieties, and the whole haploid genome is transferred. That is half set of the thing. Whereas here you take one gene, pick it up, put it to all stressful processes and insert into a recipient plant. Now only two things that what the American companies, multinational companies have produced are the Bacillus thuringiensis based pesticide and herbicide, that is glyphosate, Roundup based one. These are too dangerous. And let me tell you that I was one of the members of the technical expert committee appointed to the Supreme Court a few years ago. And we had studied the whole thing, and we were convinced at the time that this should not have been introduced into India, because this will it will devastate the Indian environmental situation, particularly the soils, and it will also deplete biodiversity, which is very important. And above all, it will lead to a lot of health effects. Now, many of these company people, including my friend, who was the earlier speaker, at one point of time was the view that in America, it has not produced any health effects. Now, 2014-15 papers I have given to you in the PowerPoint. I'm not showing them because I want to give more time for interaction after I have said a few words, is that Americans have now shown very conclusively over the last 20 years, several kinds of health diseases, health impairment and diseases have appeared in the United States which went on. For example, at one point of time, in 1980s, they produced tryptophan through what is called a genetically engineered method. It killed 37 people and paralyzed 1,500 people, and litigation to several $1 billion is still going on. Then they introduced in 1994 tomato called flavor saver tomato. Now this tomato was in the market shelves for about 11 months. After that, litigation started because it started gastric erosion, or in other words, you can call it ulcer. It started producing ulcer. Then immediately it disappeared from the market. And the reason ascribed was not health, but anything else. Now, what is the way out? This is where I would like to refer in the next 2 minutes to what Professor Swaminathan has developed. Today, if you take India is now having a high economic index. We are very proud of it. But we don't look at the other side. India is ranking very low in human development. India is the home to the largest number of hungry people. 280 million people don't have food before they go to sleep. And India is the home to the largest number of malnourished people, 600 million, because there are three kinds of hunger. One is caloric hunger. You can put some rice or chapatis in your stomach and see that you have eaten. But protein may not be there. So protein hunger is the next kind of hunger. Third is what we call hidden hunger. It is not enough if you have protein and caloric, but you must also have vitamins, micronutrients, and so on to have a normal, physiologically capable health. That one, if you see, out of a population of 1,250 million people, about 600 million do not have. So what is it that you need? You need a radically different approach, not a mechanized corporate approach. And India is, as a gift, is a blessing that it has got about 150 million small farmers. It is these small farmers who can accept a kind of a farming with nature, I want to use, because 10,000 years of farming has been against the nature, conquer and conquest of nature. So that attitude of the Indian and every other government should change to accepting, to evolving a method. And where is it happening? Professor Swaminathan has written numerous papers and so on. I have put some of them. And also the fact remains, why is it that 250 million people, 300 million people in India go to bed hungry? There is plenty of food. I can tell you, the world over today, we have enough food in the world to feed 10 billion people. Human population is now only 7.4 billion. But world over, there are 1.5 billion people going to bed hungry. Why? The reason is they don't have money to buy food. So what in Indian scenario very important is to develop access to food, the economic access to food. That can come only with livelihoods. And you cannot, the government's thinking, we can divert them from rural areas to urban areas is something wrong. No, technology has to come to your rescue. What they did in China, I have made visits to Beijing about 4 or 5 times, and I have heard people how much they have suffered. Their social science has been completely disrupted. So that's not a solution. You have to create rural livelihoods, on-farm and non-farm. I have produced a number of different things. One outstanding thing the world over they appreciate is what they call the trichogramma thing. If you quickly show me once, go over the slide, but I want to focus on one thing. Can I do it from here? Or? The trichogramma, what they have done, I'm giving you an example. Swaminathan Foundation has developed over 200 different livelihoods. 200, what I want is I have to go quickly over. This is important. This is a picture that I've taken from nature. You see, in 3 accounts, that is with regard to nitrogen cycle, with regard to the biodiversity loss and climate change, humankind has already exceeded things. That is why Paul Crutzen said, within the Holocene, now for example, we should be living in a period that is beginning to cool, that is beginning to set in what is called the glacial period. No, humans have finished it. They are become dominant force. They dictate orders to the Earth and the solar system. With the result, Earth is warming up and warming up and warming up. All these are in here. You can raise questions, but I'm not taking. You see the biodiversity loss. Today you have only about 10 different varieties of tomato, whereas at one point of time it was thousands. When Cuttack was set as the Rice Research Institute, India is the center of origin of rice. In the border of Orissa and Cuttack, there were about 50,000 varieties species. Today we have 10,000. What has happened? The anthropogenic destruction. This is the short variety of rice, the end, that could enable the acceptance of large amounts of fertilizers. This is in 1968, he made a statement that intensive cultivation is exploitative agriculture and we should not continue with that. This should only be used as a breathing space. This is 3 kinds of hunger. Caloric deprivation, people having no food at all. Then people having food, but they are deficient for proteins, which come from pulses, for in the case of vegetarians, and of course non-vegetarian food and so on. Micronutrient is the vitamins and micronutrients. Now this is a paper, one of the first thing when I got into this field from radiation biology, which is my favorite subject, we showed that how poverty, environmental degradation, climate change, etc. are all interlinked. This is published in Philosophical Transactions, the Royal Society, good journal. This is what I want to say. Here, for example, if you take, there are different forms of rural livelihoods which will give them, they will not make them so rich as to buy a car or something like that, but that will keep them enough food, at least 3 meals a day, they can be ensured of. Particularly one I want to develop is this trichogramma. You see, we used chemical pesticides which are injurious. They are endocrine disruptors and cause cancer over a period of time. There are a number of interesting papers about DDT that was applied about 50 years ago, and the women now, 90% of them having breast cancer in the United States. Now in this case, what happens is you make friendship with the enemy's enemy. Do you get? If, for example, I have got my neighbor having a problem with me, his neighbor will have some problem, so I make friendship with him. So this is the philosophy here. For example, that small wasp here that you see, it goes and lays its eggs on the eggs of the real pest that we have. So the parasite, which is a small tiny wasp, it goes and lays its eggs on the eggs of the pest. So what happens is, now for example, that is Helicoverpa is a cotton borer. It also spoils your brinjal, bengan, pest and all that. Now that is the wasp on the right side, on that side, trichogramma. Now if you look at it, this trichogramma goes and lays eggs here on this, and it develops, its pupae develop, and the host, that is the pest, is destroyed. Now what we have done is, this has been made into, this is a science, high-level science. This high-level science was demystified, and these women, rural women who have no land, who didn't have any income, they were trained to do this. And the consequence of that is put there, 7 health groups and so on. And in fact, 2 women were chosen for going to New York, what they call the Youth Employment Summit conference. And 2 of them, we had to train them because they have never they have never handled a fork and spoon, and they have never also had the toilet facilities and so on, and they have never sit in a chair, and such of these women had to be prepared to take up a journey to United States and come back. So the whole point is now they are getting about 2,000 rupees or something like that monthly income, which is something substantial. I'm only giving this illustration, but there are a number of such livelihoods possible. Now another important thing is the knowledge empowerment. He set up the knowledge lab to lab, land to lab, that is direct communication between the small farmers deprived of facilities of knowledge and techniques, data and so on, with the high-level institutions and so on. And it has also saved lives because we can give information to the marginal fishers who go in artisanal boats deep in the sea, and without knowing that there is going to be a cyclone and so on, they used to die. Now we provide information through inquires and so on. Now, another thing you have to prepare. The global warming is real. The sea level is increasing. What do you want to do? Will you give up your paddy cultivation? No. Learn it from what you call this Kuttanad in Kerala. There for thousands of years, these Keralites have been raising rice below sea water level, like Dutch polder system. They have developed their own, in fact, far better polder system, and they grow. Now, see what is happening. They can grow rice during some time, then coconuts are also giving them coconut for livelihood, and fish, which grows very easily. This is something that we had also put up in IG car for demonstration purposes. Now, the other thing is, there are crops, God has given you enough biodiversity. There are protein-containing crops, oil-containing crops, which love seawater, So the latest technology that Professor Swaminathan is developing is to develop what is called halophytes. Halo means salt. Halophytes, plants which love salt and grow. So if you take that one, then you will not have the problem. Tomorrow you will get protein, but not from pulses, but from salicornia or some plant. Oh, sorry. So there are a number of them, cash crops, fodder crops, all that are halophytes which can be grown. So you can start cultivating around the seashore, because India has got, as you know, 7,800 kilometer long coastline. And if the seawater level goes up, you will have a problem. But this is a strategy, technology, the science and technology. Professor Baldev Raj asked me to talk on this, so this is very relevant to that idea. Then this is salicornia plant. Oil is rich, you can use it as salad, and you can also extract oil from it, and protein. And this grows so well in Gujarat at the moment. Thanks to the Chief Minister, now the present Prime Minister, he had encouraged all this at the time. Now this is a collection of so many different halophytes plants. It's not one, several of them are there. So now I want to skip all this genetic engineering thing which I have said and come to the... This is where words of wisdom. Man has lost the capacity to foresee and to forestall. He will end by destroying the earth. Already humans, as I mentioned, have become homo destructors. Thank you very much. I'm ready for questions.
Thank you very much. Keshwan, now it is time for questions from the audience. You can raise your flags, and then so that I can go one by one from
There is a long time, I think 1 hour is it for left.
Half an hour is over.
I think quite a, so feel free to ask any question.
Yeah. Yeah, Mr. Apara.
AK Bhatt from Atomic Energy.
Yes.
Just you referred, sir, about the death by cancer in Punjab agricultural field.
Yes.
And recently there was much hue and cry in the society that because of the excessive use of the pesticides and the fertilizers, there was a very high concentration of the radio elements in that soil, and that was one of the reason for all those cancerous diseases. So what's your opinion about that, sir?
You see, this is a good question. What really has happened is, Punjab, when I was a student, if I had gone to more places in India, that is Punjab. Because many friends, I was also a sportsman and I used to go there quite often when I was a student. Punjab never used to cultivate rice, you know that, in those days. But then what happened, the greed set in, because after the small varieties, short varieties of wheat started yielding, C. Subramaniam, Bharat Ratna, told the Punjab farmers that now we have dwarf varieties of rice, koshish karo, try karo, to aa jayega to. Then they tried and it was a bumper crop, rice. It grew as nowhere else in India. So what they did was to put wheat ke baad rice, wheat, rice, wheat, rice. Now in the process, the Punjab farmers lost something that was very precious to them. What was it? They used to grow berseem and pulses and other things between two wheat crops or cotton. Crop rotation, jo kehte hain na, this crop rotation was completely abandoned because they have to sell the market. India was buying, what you call the procurement prices were also made attractive. So I have got so many months of wheat, acha dalo. The next rice too. So it went into a disastrous cycle of wheat alternated with rice, with no leguminous crop that would fix the atmospheric nitrogen. The second thing was the political problem or political mistake, which is that electricity is free. When something is free, then what you do is to use it 24 hours. So they started running their pumps 24 hours to extract the groundwater. Now below a certain level in the earth, there are salts. Now these salts come up and water evaporates. So what settles on the surface of the soil are these salts. And these salts do not support plant growth. And thirdly, when anything grows very luxuriant, when you put fertilizer so much, the plants grow so luxuriantly. And it will attract pests. When they attract pests, what do? The same multinational companies will tell, to pest aa gaya, to theek hai, now take this pesticides. So they also have applied indiscriminately. So this is the problem. Now the way back is that many Punjab farmers, of course some of them want to quit agriculture, that is tragedy, but some of them do not want to quit that kind of agriculture and come into more of the other crops, vegetable. Some of them have been meeting Professor Swaminathan, who also goes there to give advice and so on. So there is an attempt to sort of change the situation for better.
The adverse effect was not overseen by Swaminathan?
No, I put up a photograph of his. There in 1968 in January, there was the 55th Science Congress, Indian Science Congress held at Varanasi. And he was chairman of the agricultural session. There he said that this agriculture is exploitative. This exploitative agriculture will cause harm to soil, to human health. He has used the word cancer. You will have more cancers in 1968. And what he said is, it is a need of the hour. For example, when India was having, as I mentioned about the Paddock brothers, Paul Eldridge, all condemning India, saying this should be written off. There is no hope for this country. Instead, send food aid to East Pakistan, that is Bangladesh, or Sri Lanka, or some other country. That situation was so appalling. Humiliation was worse than hunger. You see, in that situation, Green Revolution was right, absolutely right to have been brought in. But what we should have done is to have moved away to what we are trying to do now.
We should have warned the people about these adverse effects.
That didn't happen. The political reasons are there. For example, I mentioned Bharat Ratna Subramaniam himself was responsible for inducing Punjab farmers to go for rice.
Oh, no.
You see, not that I am blaming somebody departed soul, but the fact is this is what happened, historic fact.
It's a disaster. Okay.
Sir,
it is my practical experience.
Yes.
You made a mention that the various chemicals we are using for growing the vegetables and all, that is causing serious diseases like cancer and all.
Yes.
The public is aware of it, and knowing that fact, what I have done practically to grow the vegetable plants, I tried my level best for last 6 months not to use any chemicals to grow the vegetable within my house. But at one point of time I realized that unless I use some chemicals, I'll not able to get the even that lady's finger or tomato and all. A variety of diseases and coming. Is it due to the climate changes, or 20 years back I did my agriculture work, but I have not faced that problem. But now it is a serious problem.
You are right.
This is question number one.
Let me
Another thing.
No, let me answer this
Okay,
question
please.
first, because then, you see, over the years, it is again anthropogenic element that has caused this application of the chemicals. And what chemicals do when you spray, the trichogramma type parasites and predators, which will attack your pest, they are destroyed. A borer sits inside the tissue of a plant, that gets less chemical, it survives. So in other words, in fact, along with the two people I have written papers on this very subject. What really is, this is again a short-sightedness of the humans. If I apply chemical fertilizer, everything will be normal. But what really happens is, the parasites and predators are outside, are trying to attack your pest. Now they are destroyed. And I must tell you another thing also. In God's gift to mankind, there are a number of plants. For example, here in Karnataka, in Mangalore, a friend of mine, Professor Mattu Madhyastha, he once gave me a lunch which had brinjal sambar, of the kind of sambar I have never tasted. Not only the credit goes to his wife, no doubt, but much more the vegetable itself. Then he explained to me about mattu golla, that is the brinjal. And he said that this has never been affected by a single borer. Normally there are fruit and shoot borers. Never been affected in his garden. Fortunately, at the time I was visiting him, his garden was full of brinjals, and none of them had it. Really what happens is this, man tinkers the balance of the whole thing with. Now today, world over, what we agree is that no pest can be eradicated, because that's part of the bios. You know, in the Hindu mythology, they talk about Vasudhaiva Kudumbakam. That is, all species are interrelated. So even the pests are required. But what we should do is to see that they don't proliferate beyond an economic injury level. You have your share, 2%, 1%, not beyond it, because we need it. You know, this kind of a deal you have to make with the pests. And that is exactly. Today, because of the fact that chemicals have destroyed the beneficial, those who fight for you against the pests, they have been destroyed to a great extent. So this we have to restore. That is the answer. And even now, over a period of time, if you allow, the pests and the parasites and predators will come. And you will see there will be some damage. That damage has to be accepted in principles of biodiversity conservation. Right?
Yeah.
Next question is
Parmeshwara? It's okay.
Thank you.
Sir, when we see in the 60s and 70s, those time, majority farmers, they used only the, of course, this continuation of the same question. Like you used natural manures.
Correct.
But later they started using the fertilizers, other things.
You are right.
Is it not the fact that the health hazards started increasing enormously and a lot of the health hazards spreaded all over the country? And what is the steps, whether government is not thinking on that line to reduce any chemical fertilizer, then go to the natural fertilizer, the manures?
Yeah, your question is a very, very important one. Long before, I mean, tell you that my own grandfather from the police service, he was in police service in Bangalore, and then he moved to doing some farming, was natural manure and other things. Then what happened is, soon after independence, our first Prime Minister of the country, Pandit Jawaharlal Nehru, was always having a kind of a fear complex of the Bengal famine. You know, we attained independence in August 1947. In 1943-44, several thousands of people perished in what we call the Bengal famine. So to our then Prime Minister, Pandit Jawaharlal Nehru, the backdrop to Indian independence was Bengal famine. And he didn't want. That is why in one of the lectures, one of his famous addresses said, everything else can wait, but not agriculture. Now what then at the time the agriculture scientists told was, we have to shift to chemical fertilizers and chemical pesticides in order to boost our agricultural production. So this was a kind of a advice then given to our Prime Minister, that he made this declaration, and immediately he set up fertilizer companies, as you know. One of the first fiber plan itself, fertilizer companies were set up and so on. So that was the beginning of the end of the natural, you know, the manures and green manures and farmyard manures and those things like that. That is true. Today we are realizing it. For example, there are two slides which you must see. People tell you in the country, in our country, you know, in America, people have been eating this genetically modified foods for 2 decades, 3 decades, no damage. You know what the reason is? They never allowed the labeling to be put. Never allowed any shop to put this is genetically modified food. And yet, 2 outstanding surveys published last year in 2015, I have given the reference to you, will show how different diseases have gone up in the United States of America. And therefore, well-to-do people in the United States never buy anything but organically grown food. It is so expensive, but they can, if they can afford, they do it, you know. So that is the secret. So all these foods, you know, food is a medicine in many ways. For example, rice varieties like Navra, in Kerala they use it for treating some of the bone pains and arthritis and things like that. All these, some of them have. For example, banana that we eat, don't eat it as a fruit, but it's also a medicine. You see, there are a number of things. So if you are going to tinker with them, the chemical composition of these foods, through use of fertilizers and so on, through use of pesticides and so on, and most of the, for example, I'll tell you, since there is time, there was an argument, like cigarette industries, tobacco industry was telling, no, there is no association between tobacco, cigarette smoking and cancer for decades together, they managed. Now the Monsanto, the GM company, is doing exactly the same thing, although now, recently, about a year ago, now I'm paying full attention to it because I happen to be a member of the Supreme Court appointed committee, and though Supreme Court has not published our report, I am following it up along with some of my friends. One of them is a very dear colleague of mine in Baba Atomic Center. I don't know if you know, he retired, Dr. P.S. Chauhan. See, some of us are following it. And we find amazing revelations today, like health effects and so on. And I thank Mr. Jairam Ramesh, is a minister from Karnataka. He did such good thing to us by putting moratorium on BT brinjal. Otherwise, we are a center of origin of brinjals. And our brinjal industry would have been next door. Bangladesh adopted it. They are going through hell of a problem. Their brinjal industry is finished. Their small brinjal farmers are finished. So technology is something. I'm glad Dr. Baldev Raju asked me to talk about science, technology, and agriculture. For agriculture is concerned because food is very vital. My predecessor, my friend Dr. Paduran talked on medicine, but medicine comes later. First comes food. In a hierarchy of human needs, as Abraham Maslow has said, food is the most basic requirement. If there is no food, there is no health.
Where do you draw a line for striking a balance between technology and its exploitation?
Yes, but who does it? How do you do it? This is the problem. See, for example, a lot of things have happened. The powerful, Monsanto is a $1 trillion industry, powerful. They can do to any extent to change any political power with anything, both influence and there is what is called a revolving door power. The highest paid Monsanto scientist is also now the advisor to Obama. You know that? See, that is the kind of a thing which operates in the world, which is a fact. We have to, because we're all, you know, people, we are not, I'm not exceeding what you call the confidentiality of anything, but these are facts. Facts in a democratic world must be shared. Yeah.
Sir, what is the effect of this chemical fertilizers on groundwater? And if it's so, how it can be prohibited or how it can be?
The number of times, I know number of people have done it. And, for example, the chemical fertilizers that we talk about is not simply a purified compound of inorganic nitrogen fertilizer. It has so many additive, what you call the adjuvants and so on. All these pollute. Today, added to it is a big pollution in the way of electronic waste. People at one point of time used to blame everything on nuclear waste. Then one of my students, who is a professor in IIT Madras, asked me to give a lecture on waste management. And there, it was found, based on data, I could say that nuclear waste is the best thing that is ever contained in a very scientific, effective manner, and also it is not in the private domain, it is in the public domain. The government has trained good scientists to deal with them. But what do you do with the mobile phones? What do you do with the PCs? What do you do with other things? Each PC of that kind has got so much of heavy metals, and the earth cannot recycle them. So what do you do with them? And far worse, is nano waste. Nano waste, anything from 1 to 100 angstrom, doesn't have a barrier in the biological system. And once it goes, it commands the proteins to come and form its own organ. It forms a new organ, like organelle at least, not organ, organelle. Organelle is a much smaller entity. It forms an organelle. So the medical world is going to be frightened in years to come when new kinds of diseases emerge because of the nanoparticle-based wastage and so on. This is why, in the beginning itself, I used the term human sapiens, Homo sapiens, have become Homo destructus. All other animals, potential Nobel laureate talks, all other animals live in communion or live in harmony with nature, whereas human nature from the beginning, from the day of Stone Age, had been how to conquer nature. And nature certainly will be conquered, but nature will have the last laugh. Today, in the Scientific American, I think I have got one of these photographs put here from Scientific American. They talk about the planet Earth at the crossroads. At the crossroads. In the climate change. Now, another interesting thing. So many meetings have been held, COP meetings about the climate change. Ultimately, the take-home message, as one of the editorial in Nature said, the climate science and climate policies, climate politics are in two parallel worlds. The scientists can go on talking about this is dangerous, that is, but that is nothing to dent the politicians and others who attend. For instance, today, the global temperature is increased, average temperature is increased by 1 degree Celsius. If it goes to 1.5, there will be what is called a tilting point. That is the tilting point. The whole thing will topple over. And the kind of monsoons we expect always, so far India is concerned, so far our country is concerned, we say, okay, the southwest monsoon will come in somewhere off the shore of Kerala in early June or whatever it is, and that will spread across and so on. And then after the tapers, the northeast monsoon will start and so on. But that's not going to happen. Once the equilibrium, the tipping point has occurred, all this will change so drastically that you will not have any understanding of it. And also, let us note, more serious thing, as I was talking to Professor Subhash Chandran this morning, is the intergenerational inequities. For example, let us all, some of us in the wrong side of 60s and 70s might know that when we were young, we didn't have any problem of water, drinking water. When I was a student in Delhi University and my parents were living in Patel Nagar quite a distance, I used to cycle up in those days. On the way, I can drink water anywhere. Any tap, I can drink water. And also, the people were also so kind, they would put lassi, bars and other things, nimbu pani, all those they would keep. And that was a time which was moved in communion. Today, everybody has to have a bottled water. Now, let us see what is going to happen in 10 years' time. The size of the water bottle will diminish because in our generation time when we were young, about 50 years ago, that water, each one was able to get about 1800 liters of water per day. 1800 to 2000 depending upon the area. Today it is hardly 900 to 1100. And that too because many people don't get water at all. In villages, they have to go walk a long distance to fetch a pot of water. This is the situation. So this is what I call intergeneration. When we were young, we can pitch stumps and play cricket anywhere. So much of open ground was there. I have in Bangalore grown until I was about 10 or 11, and I remember that so much place used to be there. People can run. Today, every inch is filled up with concrete jungle. So the point is, again, you see the intergenerational. You had so much to yourself when you were young. You will have so little to your children. And further, there will be abysmally microscopic dimension of things. This is exactly the technology. So when you talk about science and technology, we have to understand the sustainability of it. The sustainability of it is in regard to the resources. See, way back, one of the slides will show you the paper by Donella Meadows and so on, who in 1972 wrote a paper, Limits to Growth. That is our resources. For nobody can build a house without sand, without water, without stones and so on, and wood. Now all these are becoming rare. This is what they had seen in 1972. And they said, there is going to be limits to growth. Then the powerful lobby in the United States opposed them. Powerful lobby condemned them. They are mad people, and so on. Similarly, Borlaug, who won the Nobel Prize, was totally anti-environment. Because I will tell you why. This is because there is time, otherwise you, Mr. Chairman, you control me, okay? See, the thing is, Borlaug at one point of time, 1940, Paul Muller demonstrated that DDT, dichlorodiphenyl trichloroethane, DDT, pesticide, is a remarkable thing. It can kill all the insects. And he was awarded Nobel Prize in 1948, Paul Muller. Then 14 years later, Rachel Carson wrote a book, Silent Spring. There in the Western countries, the spring is a fantastic time because the butterflies come, chirping of the birds you hear, all those things are gone. There's silent, graveyard silence. What has happened? Now, Borlaug said, this environmentalist has no business. She should mind her business. Then, people studied whether DDT is a carcinogen or not. There were divided opinions. Some 10 years ago, they said DDT is not such a powerful carcinogen. Last year, a lady scientist from Michigan, she showed, Barbara Cohen, her name, Barbara Cohen, showed, she studied, went back to California, a particular area where agriculture was thriving, where about 45 years ago, people were putting a lot of DDT and other things. Now she studied the cancer pattern, particularly in women, of those who lived there in those years. And she has found a really remarkable small window, narrow window. Narrow window is, at the time of 30, if women had been exposed to DDT, it is 100% carcinogen, breast cancers. See, this is amazing. A narrow window, much of the time nothing happens. But at that particular time, when so many different physiological changes occur, hormonal changes occur, DDT targets. This is a remarkable thing. Whereas with regard to Roundup, what country, both previous government and the present government wanted to allow, is endocrine disruptor. I want to say here, it is 100% carcinogen, and you are going to feed the people. And in one lecture I said, I was giving a lecture with regard to low-dose radiobiology, which is my favorite subject, and somebody there asked, are you saying that low-dose radiations are not harmful? I said, yes, I'm saying. I'm even adding one more. It is beneficial, I'm saying. And then he said, this is amazing. We thought it is weapons of mass destruction. I say, weapons of mass destruction are the genetically modified foods, because everybody has to eat the food, and everybody has to face cancer and other diseases and die. Not this. And go and see the Kerala population which is living in Chavara and Manavala Guruchi area. As a matter of fact, one of the former directors of the IG car, President Rodriguez, was sharing one of my talk, and then he said, I want to say one thing, I grew up in that area. Had I not grown up, he was given to a sense of humor, and he said, had I not grown up there, maybe I wouldn't have become a director of the IG car. So what I'm saying is, you see, technologies are good, and for example, today, everyone should promote nuclear energy. Why? Because Royal Society has seen that that is the only form of energy. The nuclear fuels do not add to greenhouse gases. That one thing will do. greenhouse gases. Today, if India needs more power and you go for fossil fuels, you will add up. And India is going to be the worst hit country because of the climate change for two reasons. One is the Himalayan glaciers are melting. Already 2/3 is gone from the remote sensing as we see. And if that happens, Ganges, Jamuna, Brahmaputra all become seasonal rivers like Kaveri and fighting between Tamil Nadu and Karnataka and all that kind of things. North Indian rivers also will become seasonal rivers. If that happens, just imagine what happens to the entire food production in the country, the entire ecology of the country, and the livelihoods of millions and millions of people along the Indo-Gangetic plains. So these are the issues that we have to see. It is for these reasons, in one point I said, you must give up this fossil fuel business and set up as many nuclear reactors and so on. It is not because I have been with the radiation business for a long time in my life, but the fact is that this is true. Check up if I am wrong. Yeah. You see, we have to see all these things. Technology means agriculture needs energy. And one form of, in our great grandfather's time, it was provided by manual labor as well as the animals, farm animals used to provide draft power. After that, fossil fuels came. Today, if you want more energy, even for agriculture, you have to go nuclear. There is no choice.
Okay. I have a question, Lakshmi.
Yeah, I have an observation, sir. Sir, you told about the soil health. See, indirectly, the soil health of any country has been spoiled because of the influx of the population. If we can address the issue of the population, probably we could address the issue of soil health also, because we need to sustain the population. Overnight, we cannot reduce the use of fertilizers or any other chemicals. Overnight, we cannot do it. Probably we need to have a sustained model so that we could slowly do away with the pesticides or chemicals and then manage the population and then address the issue.
I want to react to it in two ways. The first is, with regard to population, I am 1,000 times in agreement with you. This is what I said. After the independence, our governments should have given all kinds of incentives to reduce the population. You know, it is a pathetic thing. Nowhere else in India, nowhere else in the world, we have such a human population. You go to some of the international airport, every fourth person that you see is an Indian. You know, that kind of a situation. That is appalling. You can never achieve sustainability in terms of development because of our population pressure. Let me tell you, that's how it is. The second thing is, if you go to Hyderabad, there is an agricultural scientist by name Anjaneyalu. He was ICR official and ICR scientist. He resigned from ICAR system in New Delhi and came and started an NGO, and he has now over 600,000 hectares of land, all without any tinge of fertilizers or pesticides. Remarkable yield. Now, I have been following it through what is called the International Federation of Organic Agriculture Movement, IFOM, the headquarters in Brussels. And you can see how many different countries have been successful in that. After all, you see, one thing I agree, today we have got into a mess of population, not only population. My slide will show you population combined with environmental degradation. Now, what is called Indira Gandhi, in her famous speech in 1972, in Stockholm, in the United Nations Conference on Human Environment, she said, you can't treat environmental degradation alone, separated from poverty. So poverty and this form a vicious circle, and that is so true. So you see, your question is a very well balanced question. What I mean is, these are the answers. One, there is a possibility, but there is no question at all about our not containing the population, you see.
Okay. I will move on to the next question. Nagamani?
Yes, ma'am.
Sir, this garbage is becoming a nuisance for most of the cities of the country.
Yes.
So even Bangalore, we have converted that into a garbage city.
Yeah.
So now my question to you is, there are various suggestions given by various people. Wet garbage, dry garbage, classification, so many things, and how wet garbage can be converted into useful, manure for farmers.
You see, there are, again, there is a slide. There are two things. What we do is also we talk about smart villages, climate smart villages, climate resilient crops. These are terms, for want of time, I did not, now you have given me an opportunity to say a few words about it. The first thing is the agricultural waste is something that you can convert into useful products. We have trained some of these rural women, landless rural women, to start industry, small micro industry, based on converting the agricultural waste, particularly banana stems and banana leaves, all kinds of things would be littered all around, and in choking some of the rivers and water bodies and so on. So you convert it into paper boards. And Japan has a great demand for anything that is organic and recyclable. So any product that you make out of the agricultural produce is indeed recyclable. Earth is able to do it, unlike certain other things that we mentioned. So that is one thing that can convert a waste into an opportunity, and in every rural area which generates a lot of agricultural waste, whereas urban waste is different. The urban waste, we have to think of different methods. There again, cyclable and non-recyclable things will have to be separated and done. We shouldn't follow the examples of course, Japan and United States. What they do is to dump all the electronic waste into some other country. India has also was a dumping ground for a while, and now they are doing it in Japan, in China, and other countries, and so on. So that is not the solution, because they don't understand one thing. In fact, I told in a lecture in the United States, I said, the United States should take our future there is a report, United Nations report called Our Future, which is, the author of that was the Prime Minister of the Norwegian country, Gro Harlem Brundtland. I've got a photograph of her also here. Maybe it is here. This is it. Gro Harlem Brundtland. And she wrote Our Common Future. That is the title of her report, Oxford Press. And there she says, notwithstanding the geographic and political boundaries, ecologically, our destinies are intertwined. America cannot say, I have dumped it in India, because the effect of it globally through atmosphere and water is the same. So that is why she titled it Our Common Future. Irrespective of the political frontiers, the fate of humankind is ecologically entwined. So dumping doesn't solve the problem. It only delayed reaching you, and so on. So the whole point is, urban, today we have to, you see, this is where I find, I am not against what you call Mahatma Gandhi rural employment thing that's going on, which is good. But in addition, there must be a movement to start off some of the rural livelihoods in this manner. See, now whatever we have in the country or at the demonstration level, largely brought about by MS Swaminathan Research Foundation and one or two other NGOs. There must be a national policy that you supplement the free food donation or the rural employment for 100 days, etc., along with this. If only they do that, there will be what you call the generation of interest. For example, when somebody is fed free, he doesn't think he has to work. You see? So there must be a compulsion. Necessity is absolutely very essential. I think one should strive for that. That's exactly what I think.
Okay.
Thank you, sir.
Next, Nanda Kumar.
Sir, as we all are aware, agriculture in India is in doldrums.
Exactly.
And you have suggested natural farming as the effective way of countering or rather solving the problems. At the same time, we know the farmers, when they are not having any alternative, they look for immediate solutions. And there is a lot of misinformation campaign regarding organic farming, all these things. Everything is termed as organic farming, and it is all these information are fed to the farmers. Naturally, agriculture university should have been a solution to advise the farmers to move in the right way. Can you elaborate the concept of natural farming, which you are highlighting, so that they can take it forward?
Yeah, it's a very good question. You see, there are two kinds. One is what is called the organic farming. In the international sense, organic farming is a very rigorous one. That is, the soil should not have any even parts per million of trace of any chemical fertilizer or chemical pesticide and so on. So to get a certification of the international caliber is very difficult. Although what happened is, in Tamil Nadu, in Kolli Hills, we found the tribals were cultivating pineapples and millets. When we had the very sophisticated testing done of the products, we found they didn't have any residue of fertilizers, pesticides. And that is because they were too poor to afford any chemical fertilizers or pesticides. So it is a kind of organic farming, not by design, but by default, that they couldn't afford. Now we immediately linked them with some German companies and so on. They are now getting, and some of the ragi and other materials that we are getting to reinforce, or what you call the fortification of the nutrients in cereals, come from those villages. And they have now become well-to-do. Well, the other thing is, what if you can't achieve that level of organic farming is also possible in 2 other places. I spent about 5 weeks after the tsunami, 2004 tsunami, in Andaman Nicobar Islands. The Lieutenant Governor was very kind to us and had given a helicopter, so I went with 4 others to survey the whole thing and to give a report to the government how the unsustainable, because paddy cultivation was done there, which is ecologically and economically unwise. This was thrust upon by the British, because most of the people in the circular jail were either Bengalis or the Tamilians and others, from South India. They eat rice, and therefore they said you cultivate it. Now, that is not wise. We made a lot of suggestions. The coconut there, a number of Nicobar Islands, are naturally grown. Every coconut is organically certifiable. Now, has the government done anything about it in spite of a report? Nothing. So ultimately what happens is we have knowledge accumulating in individuals' pockets and the shelves, but nothing is translated into action. Now the other kind of agriculture, which is less rigorous than organic agriculture, is what is called green agriculture. In the green agriculture, I am giving an example. If you say that your paddy requires 100 kilograms of nitrogen per hectare, I will not apply all the 100 kilograms in the form of ammonium nitrate or something. Instead, I will partition it. I will give 10% in the form of ammonium nitrate, 20% in the form of what he said, farmyard manure or natural manure and so on. Rest maybe in the form of legumes. That is, there are, for example, Baba Atomic Research Center had done a marvelous mutant. There is what is called Sesbania rostrata. It came from Australia. It produces nodules in the stems, very unique crop. Now, this was having what is called photoperiodic limitation. That is, it can grow only when there is a long day length, like in summer. But if you want that to be, normally what they do is to grow Sesbania and plow it into the soil, then raise a crop of paddy or wheat or whatever. So the long day length was interfering with this. So Baba Atomic Research Center induced radiation-induced mutations in them to knock out the sensitivity to photoperiodism. It's a remarkable piece of work from Bark. And today, we have Sesbania that you can grow, and it will add about 40% nitrogen to what you say. So in other words, this is a kind of agriculture, not organic, but green agriculture. In the green agriculture, I'm saying you deviate from the chemistry-based agriculture to a large extent towards nature-based. That is the point. It has to be transition. But with regard to yield, I may again like to tell you what I said. Anjaneyalu in Hyderabad, fantastic yields. The ICR has made visits, but ICR, unfortunately, let me tell you very openly, is caught between Monsanto's GM crops and Anjaneyulu's organic crop. And this, what you call, Monsanto will pour trillions of dollars. Now they want to take over our agricultural whole operations. Whereas poor farmers cannot put even 1 naya paisa. That is the difference, what controls the whole thing.
Okay, next question.
Sir, we have started converting salt water, saline water into fresh water.
Yes.
So don't you think, sir, if we do this on large scale, then again it will create ecological imbalance?
Ecological balance will not be achieved because where will you put all the salt? So many problems will arise. See, this is what one has to see. It is exactly the same as Haber-Bosch process. You converted the atmospheric nitrogen, plenty is there. And today your earth has got so much of nitrates. And that is going to cause a lot of other problems as yet unforeseen. Some we have seen, some we know, some we do not, we have not yet seen. So this is the problem. In technology, what happens is, for example, today we have what you call an extravagant lifestyle, extravagant lifestyle. In that, every day you see, in between the cricket program, if you are watching, you will see 10 advertisements. Don't use fog, use this body odorant, that, all kinds of things. The fundamental question is, does humankind need these? Can we not live without deodorants and all kinds of things? Now, if you take, for example, ordinary bath soaps, you can get anything from 13 rupees to 300 rupees. One new soap, as we saw about a few days ago, one bar was costing about 90 rupees or something, 95 rupees or something like that, small one. So the point is, the industry today, for example, technology, when you talk about technology, the science-based technology has been diverted by few to make money. And that exactly is the reason. Take, for example, let us say we are the third richest country in the world. And why is it that you have a human index, development index, something like about 130 out of 200, and global hunger index, 52 out of 138. Your Bangladesh and Sri Lanka have better indices than us. Why? These questions cannot be answered by anybody. Not Mr. Jaitley, not by anybody else, because these are facts. You cannot.
Okay. So you mentioned that in context of Punjab, that salts coming out of deep groundwater has contaminated the soil. So is there any way to get rid of that? Or?
Yeah, that is being done, but you have to change your method. If you want to reclaim the soil, that is the word, reclamation of those soils is possible. But again, you have to deviate from that corporate-based approach to what is required as a family farming kind of thing, where you grow different vegetables, different crops. Don't grow for the same wheat and rice. Instead, grow for vegetables, grow for other kinds of things that are salt tolerant. And over a period of time, the salt dilution will happen and salt concentration will come down. See, the whole idea is, if you look at the nature has a business of harmony and cooperation, all the processes. Take hydrological cycle, take nitrogen cycle, everything it is balanced. Whereas what happens when science-based technologies are redirected towards only making money? Many technologies are good. They have solved human problems. If, for example, we still are able to exist on this planet, despite Malthus's warning, it is because of technology, no doubt. But what I'm saying is that technology, when it's not properly used, and some technologies we promote wrongly. What is one example of a technology that we are wrongly promoting is genetic modification of organisms. No doubt about it. You have learned. So many people died in the United States. No, doesn't matter. Go ahead. Right? That is the wrong thing. You see? And then again, we all know all countries in the world are hungry for energy. How do you produce energy? There are ways, but we don't want to follow them, because you create what you call all kinds of imaginary problems. You talk about Fukushima. Let me assure you, as a radiation biologist, Fukushima has done nothing to human health. Let me talk about Chernobyl. Compare Chernobyl with the Bhopal gas tragedy. Chernobyl is a small thing. Maybe less than 100 people died here and there, and none genetically affected. Whereas in Bhopal, how many thousands died? Where is the focus of the humankind? We talk about Chernobyl. And we here have imaginary problems. Says no for nuclear power reactors. But there, if they want to set up one more chemical industry, humankind probably would be more generous. You see, these are the issues.
Thank you.
Sir, I just want to ask you, sir. This why West went for GM food at all? There was no need for them. It was sparse population. But why they went for GM food at all?
You want me to tell the exact answer or what is told?
No, you tell.
Exact answer is to conquer. India, for example, many of the developing countries cannot be enslaved once again like the British did. You can only hit, for example, Dr. Baldev and others conducted 2 Pokhran tests. We could not have conducted this kind of test had we been still importing food from the United States of America. We couldn't have had the political sovereignty. We couldn't have had the national food security. And we have them. So how do you knock them out? Let me ask you a question. Simply that. Once again, these people. For example, I have told you, BT brinjal in Bengal has destroyed brinjal industry. And today they want to put it, some of them, again, there are reasons which you know, but I don't want to explain. People can be bought, even from our country. And once that happens, for example, at a time, let me tell you this much. When I was a member of the whole thing, somebody asked me, "Sir, your daughter is in the United States?" I said, "Yes, you're right." And she's married an American. Yes, yes, all right. I said, "Sir, why don't you make a trip?" I said, "My wife and I made a trip. What is the problem?" "No, sir, this time we will give you business class, and you can also go on to visit that St. Louis. They will give you $500 per day, but we will put up all. What is the reason for?" And let me tell you, without naming the person, he came to the foundation 3 times to meet. And every time, one time I had to go through the back door, get out. Once the security told me so-and-so has come, an American giant, first time, I left all my bags in my office, in my secretary's room, and went through the back door, through what you call these generators and all that kind of thing. And my driver doesn't come until about 2 o'clock when I go, but this was about 10:45 or so. So I went and hid in some place and told, "I have a driver, bulao." See, this has happened. Now that explains. And so far America is concerned, many people, including my daughter and her husband, do not touch any of this food. They get organic food. More priced, but they get it. So ultimately it is, it's a capital society. The feeling, for example, what Obama wanted to do, the healthcare and other things, did they succeed? So that is the whole thing. Now the idea here is simply political, not food. I will tell you one thing, you can quote me. The existing crop plants which the Monsanto Americans have developed will not increase the food yield like Green Revolution did, even by 1 gram per hectare. 1 gram. Quote me.
Okay. With that,
Okay. So what is the need for it? And the Monsanto company, which has put the HT, what is called herbicide tolerant, is also the manufacturer of Roundup or the glyphosate. They say, your crop will take more, so put more, I will sell it. That's it.
Yes, okay, sir. Actually, I am the farmer, came from farmer family. Till my degree, I did myself agriculture.
Good.
What the difference what I am observing from those days in these days, whatever the seeds we are using for the next crop, previous yield whatever from the crop, whatever getting, same thing we are using for the next crop. So that is one thing. But now we are unable to use those things. We have tried, but there is no any sprouting of those things. Only whatever we are getting from the market. Those are only, one more.
I got your question, let me answer.
One more thing, sir.
No, I know what you say is farmer cannot save the seeds for the next season growing. Farmer cannot save the seeds, he is unable to save the seeds from this crop to sow the next crop because it doesn't do well. That exactly is the scientific principle. Behind the seeds that are produced, BT cotton, HT cotton, everything has got that. That is known as GURT principle, GURT, G-U-R-T. That is genetic use restriction technology. The seed will kill itself if you sow it. The reason is, unless you go to the producer every time, how can he make profit? Yes. Supposing I have sold you this time and you are going to use your own seeds, mera kya ho jayega? I will be pauper. You have to come back to me every time. For example, the BT cotton seeds are sold at 1800 rupees per 400 grams. Desi cotton for 90 rupees. Yes. When a farmer buys, I'll explain that. I agree with you. 1800 rupees, 1200 rupees go to Monsanto out of that. 600 rupees, Mexico has to take a shore. Then the farmer sows this 400 grams of seed. And his problem begins with the sowing because that is a hybrid. It requires much more water than your desi cotton. It requires more chemical fertilizers. It requires more pesticides because the BT against borer. But white flies and jacids and aphids come and attack, against which this has no solution. Okay? So the farmer commits suicide. One slide I have put it, how in the Californian scientists have analyzed that the farmers' suicide in rain-fed areas of Maharashtra is directly related to adoption of the BT cotton.
Okay, so one more thing. Earlier days when we are growing the vegetable plants, okay. Vegetables they are putting some flower plants and some other different plants and all to attract the pests and all, so
Yeah,
that
right.
major vegetables will not be damaged.
You are right, absolutely right. That is the wisdom, traditional wisdom.
Yes,
We have lost that now.
now the present they are not following that.
Absolutely. You are talking from practical experience, I see. That's
Yeah, myself. That's what.
No, that is very obvious that you are a farmer. You have experience. That's
And
very
one
good.
more my observation.
please.
Now when at the time, now I am at Sriharikota. So there are so many different types of trees are there. There they are not using any pesticides or any things and for the any growth thing. Some trees when I joined there some 25 years back, same trees they are giving a very good size, more yield, big size fruits and tasty. Same plant, now it is not, no yield, size is not there and taste also is not. So what is the reason?
You know, no, not that. Senescence is
No,
true.
we are not able to understand. So what is the, it may be due to climatic changes or soil changes.
No, climate
and all,
is
we don't know.
indeed causing a problem, no doubt, but it's, unless you scientifically establish that it is entirely due to climate change, we cannot talk about it loosely. That is one thing. But the soil conditions have been deteriorating, that's well known. For example, it takes about 400 years to form 1 centimeter of topsoil, which is fertile, which can support growth. And you can lose it in one day, you know. See, that kind of problems are there, soil-related problems, soil fertility, because you apply pesticide spray and that goes to the soil and immediately the earthworms, which are pulverizers of the soil, which add to organic content of the soil, are killed. And many favorable or beneficial microorganisms are also killed, you see. So this is a process that is set in with the application of anything that is chemical, which is not natural.
Okay, we'll have one more question from Rajari.
Sir, I have not one but 3 questions.
Go ahead.
Maybe an observation. The first one is, what can be the future policy plan for producing food, either by technology using synthetic fertilizers and biotechnology or things like that, or by traditional knowledge with organic manure for sustainable living? Number 1. So you answer, then subsequently I'll tell.
See, the first question is, this is exactly what, if you go through the slides, they will show you how a transition is taking place. Professor Swaminathan calls the new system-based approach that he has introduced as the evergreen revolution. And he defines it as producing, achieving high levels of productivity in perpetuity without causing ecological or social harm. Now, for example, in the case of green revolution, yet another thing that happened was a paradox of mountains of food grains on one hand and millions of hungry people on the other. So we should avoid that also. So this is integral, this approach is integral part of evergreen revolution, where what you do is, now there are, literally speaking, world over people, some of them very outstanding brain, not only here, Professor Swaminathan, but people elsewhere have also written. MacArthur and Scher and so many other people have also done a lot of experiments to come up with how good the farming with nature is. Only thing is, our mindset has changed. Over a period of time, we think that chemicals will produce wonders, and therefore we want to judge. That is exactly one of the questions that I earlier encountered. But the point is that if you allow your time, that's why I referred to Anjaneyalu in Andhra. And he has done over 500,000 hectares, and ICR is not wanting to take it because the pressure is from elsewhere. You see, these are the things. Second question.
Okay.
But will you be recommending this particular point to the government, or whether government is having any plans to implement?
I am too small to tell government what they should do, but these are all in the published domains and so on. And if there is a meaningful, like it happened in those days of Swaminathan when he brought in the Green Revolution, if there are those kinds of people, yes. If, for example, a minister is now going to follow the footsteps of Monsanto, then he will not do it, let me assure you. But Jairam Ramesh was different, and he did it.
Okay. Restrict yourself to question later.
Yeah, number third question I will go. Second I am skipping.
We have done already.
Yes, sir. Sir, any factory product is priced according to the standard economic models. Fixed price plus running capital overheads, like that only. Typically, example is a cement manufacturer fixes his cost, price of a cement bag, whereas a farmer is not allowed to do so. Is not one of the reasons for farmers who sits in Andhra Pradesh and
you see, there are number of, for example, dealing with anything inanimate, whether concrete or steel or cement, is different from agricultural production in the field. You have numerous problems, both anticipated and unanticipated problems. You see, for example, in some cases, in some years, we had over production of tomatoes in Andhra. And I was traveling, somebody said, "Sir, 1 rupee 5 kilos. I felt sorry for that farmer. You know, what can he get with, that means he's desperate. That situation is on one hand. On the other hand, black marketing and not availability of foods, for example, onions in September month in Delhi and other places used to sell for 200 rupees a kilo. So the whole point is somewhere our production system, supply production demand system, needs to be looked into, and it should be balanced before we can talk about the prices and other things.
Okay. Last question from Simparai. Yeah. Sure. Samparai.
Good afternoon, sir. Long time back, I have seen one program in DD Doordarshan where it was shown that some farmers of some areas are injecting hormone to accelerate the life cycles of the vegetables. They have taken small bursts of that vegetables, injected the hormone, and within 1 or 2 hours, it grown in such a shape that they can sell it into the market. Now, my question is, what kind of steps, it is a long time back I have seen, we have taken to stop the inflow of these type of vegetables in market, because as a consumer, we can't differentiate them.
Absolutely, you're right. You see, this is there are a number of methods that are going on. Tomato ripening, mangoes and so on, mango season is coming in, and all kinds of these things are done. I think it is highly deplorable, the condition of food safety evaluation in our country is not up to the mark. This is a fact. You see, so many things can come in. For example, there is a big story of Monsanto suing India, government of India, over a particular gene which they had produced, found in some what you call Indian variety. I don't want to go into the details. And ultimately it turns out we don't have any means. If somebody gives a seed, that's a tragedy. Anybody can do anything and get away with. Food is indeed, if it is not properly managed in terms of safety, can become weapons of mass destruction, you see.
Yeah. Last question, please.
Sir, it is my observation is that farmers, they are producing grains, vegetables, but they cannot store that thing, and due to that they don't get money. Because they are forced to sell that thing immediately, but the profit is the businessman, they get the profit. So some years they don't get money, and so how the government, is there any plan that the government is thinking that farmers should have that type of capability of storing the foods or vegetables?
Again, I have got to let the cat out of the bag, in the sense. The government of India had appointed a commission called the Farmers Commission, Agriculture Farmers Commission, of which Professor Swaminathan was the chairman. This report was submitted in 2004. It had not seen the light of the day. Why? Because he had recommended that India needs to build about 5,000 silos, which will be probably 1/10 of the 2G scam money. If it could be spared, Punjab farmers would have been able to store their wheat and rice in godowns, not on the roadside. That would perish with rain. So the whole point is this: the technology is available, but the government of the day must understand what the people need. And it thrives on vote banks, not on our wisdom, not on our findings. You see, that's the tragedy.
With this, we'll conclude a wonderful interactive session by Keshavan.
Thank you, sir.
I will ask Dr. Nagapudi to present vote of thanks for this session.
So I can come there?
Absolutely.
Good afternoon, ladies and gentlemen. It's my proud privilege to propose vote of thanks to Professor C. Keshavan for delivering such a thought-provoking lecture. I should tell you, it was really very emotional, and we could feel the concern you have for Indian agriculture and mankind as a whole. Really, we were all moved by this, and the interaction what took place really threw more light on your knowledge and concern and what you want to do for the humankind. But the way in which you put things, good and bad, that has gone from science and technology to agriculture, it's really an eye-opener for us. I don't know who is going to really translate these things into action. Really, we are waiting for that. But still, I am a very optimistic person. I feel a day will come or a revolution will happen very shortly so that man stops destroying the planet, and he will also survive in a better life. So on behalf of all the participants here, and on my personal behalf and also on behalf of NIAS, I would like to express my sincere thanks to Professor Keshavan. Let us give him a big round of applause.
Sir, please note you have the maximum number of questions in all the
Yes, it was
so
it was very nice. And yeah, very yeah, it was more related to life of each and everybody here, so it was very nice. And I thank Dr. Raghunathan for conducting this session, and thank you all for making it so effective, so nice, and so informative. Thank you so much.